Hi everyone, welcome to Go Classes. In this lecture, we will see the complete summary of functions. This topic functions in the discrete mathematics. We will see the complete summary of functions. Okay. So let's start. What we are going to see in this session, we will see the definition of function. When can we say that a relationship is function or not? We will see the terminology related to functions like domain, codomain, range of a function, the image and inverse image. We will see the types of functions like one-to-one, on-to, bijective. Also, we will see some function operations like composition of two functions and also the inverse of a function. Okay. So this is our agenda for this session. This is a summary lecture, remember. Okay. So in this in this lecture, we will see the complete summary of functions. Okay. I am not going to discuss the concepts in a very detailed way. I will discuss all the concepts, but in a summarized way. Okay. So let's start. First, we will start with the function definition. Let's see what is the definition of a function. See, function is a structure from one set to another. Let me tell you what is a function. What is the definition of function? Function f. What is this? This is a structure from one set to another. For example, from set A to set B. Okay. So remember, function is a structure from one set to another. And what this structure will do? This structure will associate every element of set A to exactly one element of set B. So remember, function, this is a structure from one set to another set, okay, such that, such that this f, what it will do? This f will map every element of set A. F maps every element of set A, element of set A individually. Okay, individually, if you look at individually, so if you look at any element of set A, then what this function will do? This function is going to map every element of set A to exactly one element of set B. To exactly one element of set B. Okay, so remember one thing, that if you want to define a function, then you need two set. Okay, these two set, they can be same or different. Please understand, A comma B may be same or different. May be same or different. So if you want to define a function, then you need two set A comma B. And what is a function? This is a structure which maps every element of set A to exactly one element of set B. So this is the simple definition of function. Now let's see this function from set A to set B, what it will do. So this is a structure which will map every element of set A to exactly one element of set B. Okay, not more than one, not less than one. Every element of set A individually, if you look at every element of set A, then that will be mapped to exactly one element of set B. So this is the definition of function. Okay, now look at this. Tell me one thing. Is this a function from set X to set Y? This is your set X. This is your set Y. Is this a function from set X to set Y? Please tell me. You can see that your set X, that is 1 2 3 4, this is your set X, and this is your set Y, A B C D. Now you tell me, is this a function? This f from set X to set Y, is this a function? Similarly, is this a function? This G, is this a function? And similarly, this H, is this a function? Okay, so tell me what is the answer. Now you can see this f is a function. Why? Because every element of set X is mapping to exactly one element of set Y. Yes or no? Okay, look individually. See, this is your set X, your function f, that is from set X to set Y. So let's look at every element of set X. So you can see every element of set X individually, if you see, that is mapping to exactly one element of set Y. Yes or no? 2 is mapping to A, 3 is mapping to C, and you can notice 4 is mapping to B. So yes, this is a function. Yes or no? So I can say this is a function. F is a function. What about this G? Let me know. What about this G? Again, you can see, look at every element of set X. Okay, so this function G from set X to set Y. Remember, look at every element of set X. Okay, you can see every element individually, that is mapping to exactly one element. 2 is mapping to A. 3 is mapping to exactly one element, that is A. 4 is mapping to exactly one element, that is A. So you can see again, this G is also a function. Okay, this is also a function, right? And what about this H? What about this h, which is from set x to set y? So is this a function? This is not a function because you can see one is not mapping to anyone. Yes or no? You can notice that one is not mapping to anyone. Remember, in a function, what should happen? Every element of set x, every element of set x must map to exactly one element of set y. So you can notice one is not mapping to anyone. So that is the reason I can say that h is not a function. This structure h, this is not a function. Okay. Also, you can notice that this element 2, this is mapping to more than one element, right? Yes or no? Okay, so that is also another violation. So these are the violations. This one is not mapping to anyone, that is a violation. And this 2 is mapping to more than one element, that is a violation. So I hope you understood the definition of a function. What is a function? Function is a mapping from set A to set B such that what should happen? Every element of set A is associated with single element of set B. Okay. In this situation, this set A, this will be called domain. In this situation, this set A, remember, this we will call domain, and this set B we will call codomain. Okay, so this is the simple definition of function. Now, tell me, is this structure a function or not? Look at this structure on your screen and tell me, is this a function? This is your domain and this is your codomain. So from this set to this set, is this structure a function? Yes, this is a function, right? Okay. Yes, this structure is a function. Why this is a function? This is a function because every element of domain, you can notice every element of this set is associated with exactly one element of this set. You can notice this element is associated with this element is associated with this element associated with this element, and you can notice this deer is associated with this element, and this element is associated with this element. So you can notice every element of this set individually, you see individually, that is associated with exactly one element of this set. So that is the reason, yes, this is a function. What about this? Is this structure a function? From this set, this is the domain and this is the codomain. So tell me, from this set to this set, this mapping, we have given a mapping. Is this mapping a function? Yes, this is another function. Yes, this is also a function. Why this is a function? Again, the same thing. Look every element of this set, look every element of domain. You can notice every element is associated with exactly one element of codomain. So yes, this is also a function. What about this? Is this a function? From this set, this is the domain, remember, and this is the codomain. So tell me, is this a function? Yes, this is also a function, right? Yes, this is also a function because let's look at every element of domain individually. See, this element is associated with this element. Yes or no? This element is associated with exactly one element. This element is associated with exactly one element. So every element of domain is associated with exactly one element of codomain individually. So yes, this is also a function. What about this? This structure on your screen, is this a function from set A to set B? This is the set A and this is the set B. Tell me, this structure on your screen, is this a function from set A to set B? This is not a function. Where is the violation? Where is the violation? You can notice this is the violation, right? Okay, this element is associated with more than one element. I can say this element, this is associated with more than one element of set B. So that is the violation. Yes or no? So you can see this is the violation. So this is not a function, remember. Okay, you can see this is the violation. So finally, I can say this is not a function. Okay, remember, this is not a function. Okay, and you can easily see what is the violation. Okay, so this one, you can see this is the violation. So remember, every object in the domain must be associated with exactly one element in the codomain. Is this clear? Okay, every element must be associated with exactly one element in the codomain, not more than one, not less than one. Tell me about this structure. Is this structure a function from set A to set B? This is the set A, this is the set B. Tell me, is this structure a function or not? Again, this is not a function because this element is not associated with any element in the set B. Yes or no? So you can see this element, if you see this element, this is not associated with any element of set B. So again, this is not a function. Okay, so very simple. Every object of the domain, this is called domain and this is called codomain. So every element of domain must be associated with exactly one element, not more than one, not less than one. So again, I can say this is not a function. Okay, so very simple. Now let's move on. Tell me, is this a function on your screen? From set A to set B, this structure, is this structure a function? Yes, this structure is a function. Okay, because you can notice every element of set A is associated with exactly one element of set B. You tell me one thing, in the set B, this element to this element no one is mapping. Notice this element of B, look at this element of B, no element of A is mapping to this element. So is this fine? Is this allowed in a function? Do we allow this in a function? Yes, this is allowed in a function. So please focus on the definition of function. Function says that function is a structure from set A to set B such that every element of set A must be associated with exactly one element of set B. Okay, remember this is perfectly fine. Okay, no element of set A is associated with this element of set B. This is perfectly fine. This is allowed. Okay, so don't worry about it. You can notice every element of set A that is associated with exactly one element of set B. So yes, this is a function. Okay, so you can notice this is fine that nothing is associated with this element friend. Okay, so remember functions do not need to use the entire codomain. Okay, in a function we don't need to use the entire codomain. Okay, so this is perfectly fine that no element of set A is associated to this element. Okay, so this is the definition of function. I hope you understood. Okay, now let's see the next topic, that is function terminology. Okay, so now remember, if you have a set this, if you have a function from set A to set B, okay, from set A to set B. Now let's look at the terminology. So this f will be called function. Okay, this f will be called function. This is a mapping from set A to set B. Now this set A, this is called domain. Okay, and remember this set B, this will be called codomain. Okay, now you already know what this function will do. This function is going to do this, that you have this set A and you have this set B. Now what this function will do, this will map every element of set A to exactly one element of set B individually, right? Okay, so now if you look at this element, let's assume, and let's assume this is mapping to element Y of set B. Now in this situation what we will say, okay, and remember this is a function from set A to set B. This f is a function from set A to set B. Now in this situation what we will say, we will say that the image of x is y. Okay, what we will say, we will say that x is associated to y. I can say x is mapped to y. X is mapped to y. The same thing you can also say that image of x is y. Image of x is y. Okay, if you put a mirror here, okay, let me put a mirror here, then what is the image of x? If I put a mirror, consider this function as a mirror, then you can see the image of x, that is y. Okay, I can also say that the value of x, okay, the f value, I can say in this function, okay, I can say the f value of x is y. Is this clear? Means in this function, you can notice what this function is doing. This is mapping element x to element y. So I can say f value of x, that is basically y. And this I can also say that f of x, that is y. Okay, so all these things are same. Remember, x is mapping to y. I can say image of x is y. I can say f of x is equal to y. Okay, all these things are same. Okay, one more thing, we will say that this x is pre-image of y. Okay, what we will say, we will say what is this x? Notice this y is image of x. So what will be x? X is pre-image of y. I can say x is pre-image of y. Okay, x is pre-image of y. So very simple point. One more thing I want to tell you, this function, another name for function is mapping, because what a function does, it maps elements of domain to elements of codomain. So the another name for function is mapping, and the another name for function is transformation. Another name is transformation. Okay, for example, consider this set. I'm giving you a set A and I'm giving you this set B. Okay, let me give you this set 2 3 4, and this set B also I'm giving you, that is, let's assume 1 4 5 9 16. Okay, so let's assume this is set A and this is set B. Now what I'm doing, I'm defining a function from set A to set B. This function f I'm defining. Okay, and this function I'm defining like this. I am saying that f of x is equal to x square. Okay, this is the function I have defined. Remember, I am defining this function that f of x is equal to x square. Means what will be f of 2? Tell me what will be f of 2? F of 2 will be 4. Yes or no? Because remember, I am saying that f of x is equal to x square. What it actually means? What this statement actually means? This means image of x is x square. This means image of x is x square. Okay, so remember what I will do here. I can simply say that f of 2, that will be 2 square, that will be 4. What will be f of 3? That will be 9. What will be f of 4? That will be 16. So is this a function? Tell me, from this set to this set, from set A to set B, is this a valid function? Yes, this is a valid function because every element of A is associated with exactly one element of B. Okay, so you can notice f of 2 is 4, f of 3 is equal to 3 square, that is 9, and f of 4, that is 4 square, that is 16. Okay, you can see why this function is called transformation. What is the reason? Because basically what is happening in this function, if you give the input x, then what will be the output? Tell me. Then the output will be x square. Yes or no? In this function, if I give input x, if I give this input x, then the output will be x square. Okay, so you can see that function is also called transformation because this value x is transformed into x square. This function is transforming x into x square. Okay, what this function is doing? This is transforming 3 into 9. Okay, yes or no? You give the input 3, this input you give 3, and the output you will get is 9. Okay, so that is the reason function is also called transformation. I hope you understood. Okay, so very simple, all these things. Now, let's move on. Now, let's see a function. Let's see some more terminology. Okay, I'm giving you a function from set A to set B. Let's assume your set A is ABC and your set B is 1, 2, 3, 4. Okay, now consider this function. A is mapping to 1, B is mapping to 1, and let's assume C is mapping to 3. First of all, is this a valid function from set A to set B? Is this a valid function? Tell me. Yes, this is a valid function, right? Okay, because every element of set A, this is the domain. This set A, this is called domain. Every element of domain is associated with, is mapping to exactly one element of the codomain. So yes, this is a function. This is a valid function. Now, in this valid function, tell me what are the image of A? What is the image of A? What that is? Image of A. Image of A is 1. Yes or no? This same statement, I can also say that f of A is equal to 1. Okay? Because remember, this function is a transformation. In this function, if you give the input A, then your output you will get will be 1. Okay? So that is the reason you can see this. I can also say that in this function, if you give the input A, the output you will get is 1. Okay? So this A, this is your input and this is your output. Okay, so very simple point. That is the reason we use this notation. Okay, so that f of A is equal to 1. What is the pre-image of 1? If I ask you what is the pre-image of 1? Okay, remember I am asking pre-image of 1. So what is the pre-image of 1? Pre-image of 1 will be A. Yes or no? You can see pre-image of A will be 1, will be pre-image of A, that will be A comma B. Okay, yes or no? That will be A comma B. So this is the pre-image of 1. What is the pre-image of 2? There is no pre-image of 2, right? Yes or no? Okay, there is no pre-image of 2. There is no pre-image of 2. There is no pre-image of 2 in this function f. Okay, in this function f. Now, similarly, what is the pre-image of 3? That is C. Yes or no? Okay, this pre-image, another word for this is inverse image. Okay, let me tell you this pre-image, the another word is inverse image. Inverse image. Okay, is this clear? So remember pre-image, the another word for pre-image, that is inverse image. Okay, so I hope all these points are clear. Now let's move on. Now let's see the next concept, that is range. What is range of this function? What is range of this function f? Okay, see, the concept is very simple. If I ask you the domain of domain of function f, what that will be? That will be set A, that is A, B, C. This is the domain of f. If I ask you what the codomain of f, what that will be? codomain of this function f, that will be set B. That means 1, 2, 3, 4. Now, if I ask you what is the range, range means this is subset of codomain. Remember, what is range? Range means the elements of codomain which are covered. Okay, elements of codomain which you can reach. I can say reachable elements of codomain. Range means reachable elements of codomain. Elements of codomain. So tell me which elements of codomain are reachable? Which elements of codomain are in your range? Let's assume you are standing here. Okay, you are standing here in the domain. You are standing in the domain. Which elements of codomain are in your range? Range. So that range will be 1, 3. Yes or no? This is going to be the range. So remember, range is a subset of codomain. Do you agree that what is range? Range, range of f, that will be subset of codomain. That will be subset of codomain of f. Okay, so very simple point. So this is the definition of range. So let's write the definition of range. If you have a function f from set A to set B, then what is going to be the range of f? What will be that? So remember, that will be those elements which have at least one pre-image. Yes or no? So remember those elements of B. Remember, Y belongs to codomain, right? Yes or no? Y belongs to codomain and Y has at least one pre-image. Y has at least one pre-image. At least one pre-image. Do you agree with me? Y has at least one pre-image. There is at least one pre-image for Y. Okay, so this is the definition of range. I can also say that range of f, range of this function, that will be those elements of set B, those elements of codomain. Remember, those elements of codomain such that there is at least one element in the domain. There exists at least one element in the domain. Okay, such that f of x is equal to y. Okay, yes or no? Is this clear? What is the definition of range? Remember, range will have those elements of codomain such that there is at least one element which is mapping to y. There is at least one element in the domain which is mapping to y. Okay, yes or no? Is this clear? So this is the definition of range. Very simple point. Now let's move on. So we have already seen that functions are also called mapping. They are also called transformations, because you can see in this function, if I give the input x, then the output will be fx. Now tell me one thing, this input x, this will be from the domain, yes or no? This belongs to domain. So this input x belongs to domain, and this output, this belongs to codomain. Okay, so this is what this function does. So I can say here, I can say that this function is converting, this function f is converting x into fx. Very simple point. Okay. Now, so we have seen what is the definition of function. We have seen the domain, the codomain, image, inverse image, okay, and the range. So all these concepts we have already seen. Now let's move on. So the definition of function we have already seen. Look at the definition of function. Function from domain to codomain. Then what will happen? No element of domain is left unmapped. Agree with me? Yes or no? Function from domain to codomain. Then no element of domain is left unmapped. Means every element of domain must have a mapping. Also, no element of domain is mapping to more than one element of codomain. So if you combine these two, then what we will say? We will say that every element of domain is mapping to exactly one element of codomain. This is the definition of function. Now, let's look at this function. First of all, you tell me, is this a function? Let me know. Then you find the range of this function. First of all, you tell me this f from z to z. Okay, and the question is saying that mapping of n is 3n. Okay, the image of n, that is 3n. Remember, what is z? Z is integers. Z is integers. Integers means, you know what are the integers? 0, +1, -1, +2, -2. These elements are the integers. Okay, so tell me, first of all, you tell me, is this structure a function? Is this a function? Yes, this is a function, right? This is a function because every element of domain has exactly one image. Yes or no? Every element of domain has exactly one image. Now you tell me, what is the range of this function f? Let me know. What is the range here? What will be the range of this function? Range of this function will be elements which are multiple of 3, values which are multiple of 3. Yes or no? The range will be m, where m is multiple of 3. Where m is a multiple of 3. Yes or no? Is this clear? So very simple point. This is the range, because remember, this function is given to you from z to z, integers to integers, and the question is saying fn is equal to 3n. Okay, so remember, this function is from integers to integers, integers to integers. Okay, we have this function f we have. Okay, so in the integers you have 0, you have 1, you have -1, you have 2, you have -2, you have 3, you have -3, and so on. So you can notice that what this function is doing. Okay, if the input is n, then the output is 3n. I can say in this function f, if you give the input n, then the output you will get will be 3n. So you can see the mapping. What will be the mapping of 0? 0 will map to 0, 1 will map to 3, -1 will map to -3, 2 will map to 6, -2 will map to -6, 3 will map to 9, -3 will map to -9, and so on. Okay, so you can see the range, if you look at that, will be the range will be basically multiple of 3. Okay, remember, there is no pre-image of 1, right? Yes or no? You can notice this. For example, this 1, this 2. Okay, for example, 4, 5. These elements do not have any. Okay, 1, 2, 4, 5. These elements, they do not have any pre-image. Okay, so this is the range. I can say range is basically all the values which are multiple of 3. This is the range of this function. Okay, let's move on. Let's see this. First of all, is this structure a function? This structure G from set 1 to 3 to set ABC defined by G1 is C, G2 is A, G3 is A. Is this a function? Yes, this is a function, right? Okay, very simple. This is a function. What is the range of this function? You can notice the domain is 1 to 3. The core domain is ABC. And what is the range of this function? So this function is from 1 to 3 to ABC. Okay, and what this function is doing, we have a function. We have a function G. We have a function G, and we are saying that G1 is C. Okay, so you can notice 1 is mapping to C in this function G. Okay, G2 is A and G3 is A. Okay, so here you can notice G1 is C, G2 is G2 is A, and G3 is A. So what is the range here? Range of this function. Range of this function G. I am asking range of this function G. So that will be basically, that will be A comma C. Yes or no? Okay, because this element B has no pre-image, right? I can say there is no pre-image for B. There is no pre-image for B. No element of domain is mapping to B. Agree? You can see in this domain, no element is mapping to B. Okay, so very simple. Now let's move on. Tell me about this one. What is the range for this function? You have a function z to z, okay, from integers to integers. First of all, you tell me, if I write this fx equal to x square, is this a valid function? First of all, you tell me, is this a valid function? Means, is this a function at all? Let me know. Is this a function? And the answer is yes, because look at any element of the domain, you will have only exactly one output. Yes or no? For example, tell me what will be the output. You look at any element of the domain. This is your domain Z, this is your core domain, okay, and this function f is given to you. You look at any element, for example, this element. What is the image of this element? This element will map to 4. Yes or no? Okay, you can see this element will map to 100. Okay, so you can look at any element. This element will map to 0. Okay, so very simple that every element of the domain has exactly one image. Okay, so this, yes, this is a function. What is the range of this function? Tell me. For this function, what is the range? Range of this function f. First of all, you tell me, is there any pre-image? What is the pre-image? What is the pre-image of 2? Is there any pre-image of 2? What is the pre-image of 2? Tell me. I am asking what is the pre-image of 2? Pre-image. I am asking pre-image of 2. So pre-image of 2, that is none. No element is mapping to 2. Yes or no? Okay. No element is mapping to 2. And what is image of 2? What is image of 2? Image of 2, that is 4. Right? Yes or no? Okay, so very simple. Image of 2 is 4. Now you tell me what is the range of f. So you can notice the range of f, that will be all the square values. Okay, like this: 0, 1, 2 square, 3 square, 4 square, 5 square. Okay, so this is the range. Okay, very simple. So this is your range. Very simple. Okay. Is range equal to codomain? Here you tell me, range equal to codomain or not? Range is not equal to codomain, because what is codomain? Codomain is set of all integers. This is the codomain, all integers. Okay, let's move on. What about this? This structure, is this a function? I am giving you from natural numbers to natural numbers, and I am saying that f of n is equal to n by 2. Tell me, this structure, is this a function? Is this structure a function? First of all, what is n? Let me tell you, n is natural numbers, right? What is n? N is natural numbers. That means 1, 2, 3, 4, and so on. Okay, so this is n. N is natural numbers. Okay, so is this a function? The answer is no. This structure is not a function, because what the image? Tell me, what the image of 3? Let me know, what the image of 3? Can anyone tell me what the image of 3? I'm asking image of 3. There is no image of 3, none. Yes or no? Because remember, your codomain is natural numbers. Okay, please understand that natural numbers, two natural numbers. Okay, it is like 1, 2, 3, 4, and so on. And here also you have 1, 2, 3, 4, and so on. Now tell me, what the image of 3? There is no image of 3, right? Okay, yes or no? The image of 2 is 1. Okay, the image of 5, what are the image of 5? There is no image of 5, right? Okay, so this is the idea, that this structure, look at this structure, this is not a function. Okay, this is not a valid function, because image of 3 does not exist. Okay, there is no image of 3. Okay, so very simple. So you can notice this structure, this is not even a function. Okay, this is not a function. Now let's move on. Now let's see this. Determine whether f is a function from z to real numbers. Tell me. Z, this is integers. Okay, what is Z? Z is integers. Now try this question. Pause the video and try this question. Integers, and these are real numbers. Okay, so let's solve it. First of all, you tell me, is this a function from integers to real numbers? Is this a function? This is not a function. Why this is not a function? Because you can notice what will be f2. F2 will be plus 2 comma minus 2. Yes or no? F2 will be 2 comma minus 2. So that is the reason this is not a function. Okay, very simple. What about the last one? What about the part C? That is also not a function. Why this is not a function? Tell me, what the reason? Tell me what the image of 2. What the image of 2? Let me know. Do you know what the image of 2? Image of 2 will be 1 by 0. Yes or no? Image of 2 will be 1 by 0, which does not belong to real number. This does not belong to real number. Yes or no? Remember, this does not belong to real number. Please understand one thing, that this 1 by 0, this does not belong to real number. Also, this infinity, remember, this does not belong to real number. Okay, this infinity is not a number. This infinity, this is not a number. Okay, is this clear? This is not a number. So you can see this 1 by 0. Okay, what we will say? We will say this is infinity. But remember, infinity is not a real number. And your codomain is real numbers. Okay, this is our codomain. This is our codomain. Do we have infinity in this codomain? Do we have this infinity in the codomain? No, this does not belong to our codomain. So I can say the image of 2 does not exist. Yes or no? There is no image of 2. Very simple. What about the option B? Yes, this is a function. Okay, this is a function. You can easily notice this is a function. Every element of every integer has exactly one image. Is this clear? Okay, so you can see option B. Every element, every integer will have exactly one image. Okay, and what about this option A? See, option A is saying, please look at option A, function from integers to real numbers, and we are saying that fn is equal to plus minus n. Okay, so tell me what will be f2? What will be f2? F2 will be what? Let me know. This is integers, this is real numbers. This 2 will map to 2 also, and this 2 will map to -2 also. So that is the reason I can say this is not a function. Is this clear? Okay, this is not a function, right? So very simple. Is this clear? Let me know. And what about option B? Option B, that is from integers to real numbers. Okay, f of n is equal to square root of n square plus 1. Now here you can easily see that this every element has exactly one image. Okay, for example, tell me what will be f0. Let me know what will be f0. F0 will be square root of 1, and that is 1. Is this clear? Square root of 1, that is 1. Tell me what will be f2. That will be square root of 5. Yes, this is a real number. Okay, this is also a real number. This is also a real number. Okay, for example, if I ask you what is f of -2, f of -2, that is square root of 5. That is also a real number. Okay, so very simple. One more thing I want to ask you. Can anyone tell me what is square root of 9? Will it be 3 or will it be plus minus 3? Anyone? Anyone? So remember, this is correct. This is not correct. Okay, so remember, this square root of 9, that will be 3. That will not be plus minus 3. But if I say, one more thing, if I say x square is equal to 9, now, what will be x? Now x will be plus minus 3. Okay, now the x is going to be plus minus 3. So remember, if I say x square is 9, then from here I can say that x is equal to plus minus square root of 9. Okay, now remember, this will be only 3. This will be 3. So finally you will have plus minus 3. Okay, so I hope this point is clear. So remember, if I say square root of 16, that is not plus minus 4. Okay, remember, square root of 16 will be 4 only. Okay, now let's move on. Now let's see function equality. When can I say two functions are equal? When can we say that two functions are same? Okay, let me give you one example. Consider this function from set 1 comma 2 to set of natural numbers, and I am saying that f of x is equal to x square. Another function I am giving you g, another function g I am giving you, that is from 1 comma 2 to integers. Okay, and I am saying g of x equal to x square. Now you tell me, are these two same function or not? Are they same or not? Same or different? These two functions, and tell me, are they same or different? Please tell me quickly. Look at this structure, which is mapping 1 comma 2 to natural numbers fx equal to x square. This structure is mapping 1 to integers gx equal to x square. Are they same or different? Let me know. The answer is yes, they are different. Okay, they are different, because remember, when can I say? Because their codomain is different. These two functions are different because their codomain different. Okay, their codomain is different. So when can you say two functions are same? Let me know. If you have two functions, let's assume you have function f from set A to set B, and you have function g from set C to set D. Okay, from set C to set D. Now tell me, when can I say f is equal to g? When can I say f comma g are same? When this will happen? If and only if three things must happen. What are those? Domain must be same. Okay, remember, domain of both of them must be same. Domain of f must be same as domain of g. That means this a must be equal to c. Is this clear? Okay, that means a must be equal to c. Is this clear? Please tell me. Let me know. Okay, so the domain must be same. What the second thing? The second thing, codomain must be same. Codomain must be same. What that means? That means B must be same as D. Okay, is this enough? Is this enough to say that these two functions are same? These two functions f comma g are they are same? Is this enough? No, this is not enough. The mapping also must be same. Okay, yes or no? The mapping also must be same. Same mapping. What it means? It means that for all elements, for every element of domain, for every element of domain, what should happen? Tell me. It should happen that f of a should be same as g of a. This should happen for every element of domain. Is this clear? Okay, for every element of domain, this should happen. I hope you understood. Is this clear? Same mapping, so automatically range will be same. Same mapping. Okay, is this clear? Let me know. But tell me, instead of same mapping, if I say same range, will that be enough? Now, is this definition correct? If I say these three things, domain same, codomain same, range same, is this definition correct? Please tell me. Is this definition correct? Let me know. Please think about it and tell me. No, this definition is wrong. Okay, let me give you one counter example. Consider this 1, 2, 3. Okay, for example, A, B, C to 1, 2, 3, 4. Now, I'm giving you this function f. Okay, A is mapping to this, this, this. Okay, I'm giving you another function A, B, C 1, 2, 3, 4. I'm giving you this function G, where A is mapping to 2, B is mapping to 1, and C is mapping to 3. Are they different or same? Please tell me, are they different or same? You can clearly see G is not same as F because mapping is different. Okay, G is not same as F because you can easily see that G of A is not same as F of A. Okay, but here you can notice range, domain, codomain, everything is same. Yes or no? If you look at for F comma G, if you see domain same, codomain same, and range is also same, but still not, but still what I can say, F is not equal to G. Okay, so I hope you understood the definition. Is this clear? Please tell me. So this is the definition of function equality. When can I say two functions are same? You have a function from set A to set B, another function from set C to set D. When can I say they are same? They will be same when domain is same, codomain is same, and mapping is same. Means for every element of domain, the FA and GA must be same. Is this clear? Please tell me, is this understood? Theoretical question can be created on this topic. When can I say functions are equal? Two functions are equal if and only if their domain same, codomain same, and their mapping is also same. For every element, mapping must be same. For every element of domain, you must have same mapping. Means FA and GA, they must be same. So this is the definition of function equality. You can easily read this. Whatever we have seen, that is written here. Okay, let's move on. Now let's see function representation. A student is saying means image of every element should be same. Yes, that's what we are saying, that mapping is same. Same mapping means the image of every element of domain must be same. You can see for every element of domain, FAGA must be same. Their image must be same. And this should happen for every element of domain. So same mapping. Okay. Now let's see what is function representations. What are different representations of a function? Same function you can represent in many different ways. Now we will see those representations. For example, consider this function. This domain is given to you, that is 1, 2, 3, and codomain is given to you, that is 1, 2, 3. So this is a function from domain to codomain. This is a function f. Now, this representation we have already seen, that what is f1? If I ask you, what will be f1? The image of 1, that will be 2. The image of 2, that will be 1. And the image of 3, that will be 3. Okay, so this is one representation of function f. This same function f, you can represent using set representation also. Okay, using set representation. Let me tell you the set representation of f. The set representation of f will be like this. Okay, basically function is also a set, remember. Function is also a set which contains ordered pairs. You can notice that 1 is mapping to 2. So I can say 1 is mapping to 2. You can see 2 is mapping to 1. You can see 3 is mapping to 3. So you can see this is another representation of function. This is the set representation of function. Okay. So you can see first element is coming from domain, second element is coming from codomain. Is this clear? You can see 1 is mapping to 2. You can see 2 is mapping to 1, 3 is mapping to 3. Okay, so this is another representation of the same function. I hope you understood. Let me tell you, there is another representation you can create. For example, table representation also you can create. Okay, table representation. What is that? That is like this. You can put domain here. Okay, you can put domain here and you can put codomain below. Okay, like this also you can put. So this is your domain, remember? Okay, and you can put codomain here. For example, 1 is mapping to 2. So remember, it will be like this, that 1 is mapping to 2, 2 is mapping to 1, 3 is mapping to 3. Okay, so this is another representation. It means 1 is mapping to 2. It means 2 is mapping to 1. Okay, so very simple. So these are some representations, some different representations. There is a graph representation also. Okay, you can plot a graph also. For example, this function, the same function that we have seen previously from 1 to 3 to 1 to 3. If you want, you can plot a graph also. We are saying that f1 is 2, f2 is 1, and f3 is 3. What you can do, you can create a xy graph also. You can create this x-axis, y-axis, your favorite from your school life, x-axis, y-axis. Okay, so on this x-axis we put the domain, on the y-axis we put the codomain. Okay, for example, this is 1, this is 2, this is 3, this is 1, this is 2, this is 3. Okay, so like this. Okay, so finally you will have this. 1 is mapping to 2, so you will put a point here. 2 is mapping to 1, you will put a point here. 3 is mapping to 3, you will put a point here. So this is another representation. Is this clear? Let me know. So this point indicates that 3 is mapping to 3. Okay, this point indicates that 1 is mapping to 2, and this point indicates that 2 is mapping to 1. Okay, so this is another representation. These are simple representations, nothing fancy, nothing hard here. For example, you can see this is a function. This is very popular representation. Do you agree with me? So far, we are using this representation or not to understand the functions. If you want to teach function chapter to any children, any child, okay, then what you will do? You will basically start with this representation. So this is a famous, or I can say popular representation. This is your domain. We put the domain here, and we put the codomain here. You can see A is mapping to alpha, B mapping to gamma, C mapping to gamma, D mapping to beta, E mapping to beta. Okay, so this is another representation. This same function I can represent like this also. Okay, like this also we can represent. So here this domain we will put on the rows. You can see on this row, this domain we are putting. So domain we are putting on the rows, and codomain we are putting on the columns. Okay, so you can see A is mapping to alpha, B is mapping to gamma. Okay, so the same function, remember this same function you can represent like this also, and this same function you can represent like this also. Okay, so let's call this function R. So you can see this is your function R, I can say. So this is another representation, that A is mapping to alpha, B is mapping to gamma, C mapping to gamma, and so on. So these are different representations of the same function. For example, you can see this representation. Okay, here you can notice this X. Here again, this is domain. We put the domain here. Okay, and this is your fx. So you can see that 0 is mapping to 3. Okay, so what is f0? Tell me. F0 is 3. What is f1? F1 is 3. What is f2? F2 is 2. What is f3? That is 4. Okay, and so on. Now this same representation you can put like this also. These are different representations. This is another representation, that 0 is mapping to 3, 1 mapping to 3, 2 mapping to 2. Okay, yes or no? Is this clear? Please tell me. So this is another representation. So far we have seen different representations of a function. Now you tell me, in the GATE exam, if they give you this representation or this representation or this, any representation, if they give you, can you understand what is the function? What is the mapping? Which element is mapping to which element? Tell me. All these are simple representations, nothing fancy here, nothing hard here. Now let's see another function representation, that is piecewise function. Okay, piecewise function. This is another important function representation. Okay, what is this? Let me tell you. See, look at this function. Can I say this is a broken function? This is also called piecewise representation of function. Piecewise representation. Here you can notice what we are saying. We are saying that if n is even, if the input is even, then the output will be minus n by 2. Otherwise, means when n is not even, when the input is not even, then the output will be n plus 1 by 2. Okay, so this is another description of a function, or I can say this is another representation of a function. Okay, so remember, function may be specified piecewise. Okay, is this clear? Different rules apply to different elements. When the element is even, then the output will be this. And when the input is not even, then the output will be this. So this is another way to describe a function. And this type of function are called piecewise function. This is just a name. Don't worry about the name. The name does not matter. I'm just telling you that this is another description. Another way to describe a function is this. Okay. So let's focus here. Let's assume you have a function from integers to integers, and I'm describing like this. F of n is equal to, remember, f of n is output or input? F of n, that is input or output? That is output, right? Okay, that is output. Okay, you already know that is output, because in this function, when the input is n, then the output will be fn. So you already know that this n is the input, which is from the domain, and this fn is the output, which is from the codomain. Now we are saying that the output will be minus n by 2 when n is even. When n is even. Okay. And otherwise means n is odd. Okay, n is odd, then the output will be n plus 1 by 2. Now, can anyone tell me what will be the image of 0? See, 0 is a even number. Okay, and when the input is even, you can see when this input is even number, then the output will be minus n by 2. That will be minus 0 by 2, and that is 0. Yes or no? So f0 is 0. Tell me what is f2? F2 will be minus 1. What will be f minus 4? That will be 2. Okay. Now you tell me what will be f3? This is odd. Yes or no? This is odd. So when the input is odd, when this input n, when this is odd, then the output will be n plus 1 by 2. Output will be 3 plus 1 by 2. That is 2. Yes or no? And similarly, tell me what is f minus 3? That will be minus 3 plus 1 by 2. And that is minus 1. Yes or no? Is this clear? So this is another representation of a function. Tell me the answer for this question quickly. Given the following piecewise function, find f of minus 7. This description is given to you. The question is saying that when the input is less than 7, output will be 3x plus 1. When input is from 7 to 12, output is 7x. When input is greater than 12, then the output is 7 minus 3x. So this is the description of a function. Now here you can see what will be f of minus 7. You can see here f of minus 7. So this is basically x is less than 7. Okay, so that is the reason f of minus 7 will be 3 multiplied by minus 7 plus 1. That will be minus 20. So the answer for this question will be minus 20. Okay, can anyone tell me what will be f of 7? F of 7. For f of 7, this will be applicable. Yes or no? So that will be 7 multiplied by 7. That will be 49. Okay. So this is the idea. I hope you understood. Now let's move on. Tell me the answer for this question. Evaluate the piecewise function fx equal to, when input is less than 0, the output is 2x plus 3. When input is greater than equal to 0, output is 4x plus 7. So in this question, what will be f of minus 4? F of minus 4, input is less than 0. So the output will be 2 multiplied by minus 4 plus 3. And that value is basically minus 5. Okay. What is the next one? What will be f0? You can notice when input is greater than equal to 0, then the output will be 4x plus 7. 40 plus 7. That will be 7. Okay. And what about the last one? F of 4. F of 4, you can see this input, this is greater than equal to 0. So the output will be 4 multiplied by 4 plus 7. Okay. So you can see that is a 23. Yes or no? So very simple. So this is the idea. So f of -4, that is -5. So this is the idea of piecewise function. Now let's see the next concept, that is image of subset of a domain. Now we are going to find image of subset of domain. Look at this function. This function from 0, 1, 2, 3, 4 to ABC. So you can see this is the domain and this is the codomain. Anyone want to tell me what is the range? In this question, what is the range of this function f? Tell me. What is the range? You can see 0 is mapping to A, 1 mapping to C, 2 mapping to B. So here the range is basically equal to codomain, right? Range and codomain here both are same. Okay. Now tell me, if I ask you what the image of 4, what you will say? Image of 4, what that will be? Image of 4 will be B. Okay, that is fine. But if I ask you what is the image, see, image of 4 is B, that is fine, that is very good. But if I ask you what the image of subset of domain, for example, if I ask you what the image of 3 comma 4, now what do you think, what will be the answer? I am asking image of subset of domain. This is subset of domain, right? I am asking what the image of 3 comma 4. Okay, very simple. Just put what the image of 3, that will be A. What the image of 4, that will be B. So the your answer will be A comma B. Very simple. Okay, just put image of 3, image of 4. Is this clear? So very simple. So here the answer will be A comma B. This is very intuitive, right? Okay, agree? Now, for example, if I ask you what the image, tell me image of this set. Okay, image of, I am giving you a subset of domain. For example, what the image of 2 comma 4? Tell me what that will be. Image of 2 comma 4. You can see, just put image of 2. Image of 2 is B. Image of 4, that is also B. So your answer will be only B. Yes or no? Because image of 2 is also B. Image of 4 is also B. Okay, so your answer is only B. So this is how you can understand the image of subset of domain. Image of subset of domain. Is this clear? Please tell me. Very intuitive concept, right? Can anyone tell me what is the image of the whole domain? If I ask you the image of entire domain, what that will be? Let me know. What will be the image of entire domain? That will be range. Very good. That is the definition of range. Okay, so the image of entire domain, that will be same as range. Very simple point. Okay, I hope all these points are clear. Very simple. Now tell me, so if you have a function f from set A to set B, then what the formal definition? Let's assume S is a subset of A. Then what will be the image of S? What do you think is the formal definition? I am asking image of S. S is subset of A. What will be the image of S? Very simple, very simple. For every element of S, right? See what you do. For every element of S, just find fx. Do you agree or not? For every element of S, just put fx in the image. Okay, so this is the idea. Okay, for every element of S, just find the image. For every element you find, and that will be your image of S. So this is the definition of image of S. I hope you understood. Okay, so very simple point. Now let's move on. So you can see this is the definition of image of S. I hope you understood. See, the same definition I can also write like this. What will be image of S? The same definition I can write like this. Image of S will be elements of codomain, right? Yes or no? Elements of codomain. This Y belongs to codomain such that for some element of S, Y is the image. Yes or no? There exists some element in S such that fx is equal to Y. Okay. So this is another way to define the image of S. I hope you understood. See, very simple point. This is a function from A to B, and S is a subset of A. Now I'm asking what the image of S. So that will be elements of codomain such that there is some element in this S who is mapping to Y. Yes or no? Who is mapping to Y? Very simple. Or another simple words, that is For every element of this set S, just find what is the image. Okay, for every element of this set S, find what is the image that is your image of set S. Okay, so this is the idea. Now let's move on. Now we will see what are the types of functions. Some special types of functions, these are very important. One is injective function, surjective function, bijective function. So let's study them one by one. First, we will study what are injective functions. The another name for injective function is one-to-one function, or you can say injective, or you can say injection. Okay, so these are different names for the same function. Remember, injective, the another word is one-to-one, or you can say injection. Now let's see what is the definition of injective function. The definition is very simple. Injective function simply says that different elements of domain must have different images. Yes or no? These type of functions are called injective functions. The definition is very simple. Do you agree with me? This is simply saying that if you are different elements, then you must have different images. This type of function will be called injective function. Okay. So very simple point. Different elements of domain have different images. I can simply say that if you have a function f a to b, then when can I say f is injective? Then f is injective. F is injective. Another word for injective is one-to-one. Okay. F is injective if and only if. F is injection. This function f is injection if and only if different elements of domain have different images. Means for all for all x comma y in A, what I can say? For all x comma y in A, what I can say from the domain? For all elements of the domain, what I can say? For all the elements of the domain, I can say if these elements are different, then their images also must be different. Their images also must be different. Is this clear? Please tell me. Is this understood? Very simple. That different elements have different images. Okay, for all elements of the domain, I can say, for all x comma y in the domain, I can say that if they are different, their images are also different. Very simple. The same definition I can also say, tell me, I can also say the same definition I can write like this. I can say that for all x comma y in the domain, what I can say? I can say if their images are same, then what should be the elements in the injective function? If two elements have same image, let's assume you have an injective function f. You have injective function f from set A to set B. I am saying you have an injective function, means different elements, different image. Now you tell me, just tell me simple point that if two elements are mapping to same element, if 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 fa and fb are same, means I am saying that fa and fb are same. If they are mapping to same element, if fa fb are same, then what can you say about a comma b? If fa fb are same, what you can say about a comma b? Tell me. See, different elements must have different images. Different elements must have different images. These two elements have same image, then these two elements are also same. Okay, then a is equal to b. Okay, these two elements are also same. Very simple. So this is the definition. Remember, injective function means different elements of domain have different images. So for all elements of the domain, what I can say? I can say if images are same, if a comma b have same image, then they are also same. Then they are also same. Okay, so you can use this definition or you can use this definition. Both are fine. Is this clear? Okay, so this is the definition of injective function. Different elements have different images. Means in the domain, I can say for all the elements x comma y, I can say if elements are different, their images must also be different. Similarly, I can say that if images are same, then the elements are also same. Very simple. Tell me, is this injective function? Look at this function and tell me, is this injective? Can I say different elements have different images? Yes, this is injective. Okay, yes or no? So this function is injective. What about this function? Is this function injective? This function is not injective. This function is not one-to-one function. Okay, because you can easily see that different elements, for example, this element, they have the same image. Okay, yes or no? Different elements have same image. You can see these two are different elements. They are different, but they have same image. So this is not a one-to-one function. What about this one? This mapping, this function, is this injective? Yes, this is also injective. Okay, because you can notice different elements have different images. So this is also injective. Very simple. Okay, this is your favorite Hermione Granger, a Muggle from Harry Potter. Okay, so let's move on. So this is the definition of injection. I hope you understood. Okay, let me take this example. Fx equal to x square. Now tell me, this will be injective when from natural numbers to natural numbers is this injective, or from integers to integers is this injective? In which case this f is injective. This function fx equal to x square, this will be injective. Yes, in this case f will be injective, right? In this case it is injective, but here f is not injective. Why f is not injective when you have integers to integers? Okay, tell me. So very simple, because 2 comma minus 2, they have the same image. Okay, so in this case you can notice that different elements have same image. Different elements have same image. They have same image. So that is the reason. Remember, when you have integers to integers, this is not an injective function. But when you have natural numbers to natural number, then it is a injective function. Okay. In this case, what is happening? In this case, you can notice that different elements have different images. For example, natural number, sorry, the domain and codomain, they are natural number. 1 is mapping to 1, 2 is mapping to 4, 3 is mapping to 9, okay, and so on. So you can notice different elements have different images. But when you have integers to integer, when your domain and codomain are integers, then you can easily see that this is not an injective function, because different elements have same image. Okay, so this is the definition of injective function. Now let's move on. What about this function gx equal to x power 4 minus x? So this g from real numbers to real numbers, and I am saying that gx equal to x power 4 minus x. Is this a function or not? Is this a function, injective function or not? Is this an injective function or not? First of all, yes, this is a function. Function, yes, this is a function, right? Because for every real number, you will get unique real number. Okay. If your input x, you take any real number as an input, then your output will be unique real number. So this is a valid function, but this is not injective. Why this is not injective? Tell me. What is the reason this is not injective? Anyone want to tell me what is the reason this is not injective? Because you can notice that f0, f1, they have the same image. That will be 0. Yes or no? Different elements have same image. These two different elements, 0, 1, they are different elements, but they have same image. Tell me what is f2? What is f2 and what is f minus 2? They are different. Okay, f2, that is 14, and f minus 2, that is 18. Okay, so they are different. But you can easily see here, this is your counter example. You got the counter example that different elements have same image. So this is your counter example. Okay, let's move on now. Tell me the answer for this question. Quickly read this question and tell me the answer. Injective function from codomain point of view. The definition of injective function from codomain point of view. Tell me so far the definition of injective function that we have seen. What is that? That is from domain point of view or codomain point of view. So far the definition that we have seen, that is from domain point of view or codomain point of view. So far we have seen from domain point of view, because so far we are saying that injective function means different elements of domain have different images. Yes or no? Okay, different elements of domain have different images. So far the definition that we have seen, that is from domain point of view. Now I am asking the definition from codomain point of view. Injective function definition. Let me know what that will be. Read this and tell me the answer. Very simple. Okay. Every element of codomain has how many pre-images? Must have how many pre-images? Must have at most one pre-image. Yes or no? So for this question, the answer will be option B. Okay. Is this clear? See, in the injective function, notice one thing. In the injective function, if you have an injective function, you have an injective function f from A to B. Okay, tell me quickly. In this B, if I give you some element y, what can you say about its image, pre-image? Tell me quickly. This is your injective function f. Remember, I am giving you injective function f. This f is injective function. So what can you say about this y? Is this possible? Is this possible that two elements are mapping to it? Is this possible? Is this possible? Two elements are mapping to it. This is not possible because it is an injective function. So this is not possible, right? Okay, because f is injective. F is injective. So this is not possible that this element has more than one preimage. More than one preimage, that is not possible. Agree with me? More than one preimage is not possible in the injective function. But is this possible that this element has no preimage at all? This element has no preimage at all. Is this allowed? This element y has no preimage at all. Is this allowed? Yes, this is allowed. Okay. Yes, this is allowed. Yes or no? Is this clear? And this is also fine that this element has one preimage. This is also fine. Okay. This is also allowed. So I hope you understood. So finally, what I can say in the injective function, overall, what I can say in the injective function, for every element of the codomain, you must have at most one preimage. Yes or no? You cannot have more than one preimage. In the injective function, elements of the codomain cannot have more than one preimage. Okay, so finally your answer will be each element of codomain must have at most one preimage in the domain. So for this question, the answer is going to be option B. Understood? So this is another definition of injective function. Please tell me. So you can easily see that each element of the codomain must be associated with, or I can say has at most one element of domain associated with it. So this is the definition of injective function from codomain point of view. Okay, let's move on. Now we will see the definition of surjective function. This is another special type of function. Another name for this function is onto, or you can call it surjection, or you can call it surjective. Let's see. This surjective function, what this says? This says that every element of codomain must be covered. Very simple. This type of functions in which every element of codomain is covered, that will be surjective function. So I can say range equal to codomain. When range is equal to codomain, this type of functions will be called onto function, or I can say surjective function. These are different names for the same function. Okay, so remember, every element of codomain has at least one pre-image. Is this clear? Every element of codomain must have at least one preimage because every element of codomain must be covered. Range must be equal to codomain. So every element of codomain must have at least one preimage. So I can say that if you have a function from set A to set B, when can I say f is surjective? When can I say f is onto? F is onto if and only if for every element of codomain. Is this clear? For every element of codomain, what must happen? What must happen? There must exist, for every element of codomain, there must exist. What should happen? There must exist some element whose image is y. Whose image is y. Is this clear? Let me know. Please tell me. Did you understand? This is the definition of onto function, that for every element of codomain, there must be at least one element in the domain who is mapping to y. Okay? Very simple. If you want in simple words, I can say that for every element of codomain, what I can say? I can say that there is at least one element in domain who is mapping to y. There is at least one element x in domain which is mapping to y. Which maps to y. And this would happen for every element of codomain. So this is the definition of surjective function. It simply means that every element of codomain must be covered. It simply means range must be same as codomain. So this is the definition of surjective function. I hope you understood. Okay. So let's move on. Now what about this function fx equal to x square from integers to integers? Is this onto? Tell me. From integers to integers, fx equal to x square, is this onto function? This is not onto, right? Why this is not onto? Because for example, element 3 has no pre-image, yes or no? I can easily see that no pre-image for element 3. No pre-image for 3. Very simple. Actually range is not equal to codomain. You can also see that range is not equal to codomain. Okay, your codomain here is integers and your range here is square numbers like 0, 1 square, 2 square, 3 square, 4 square, and so on. Okay, so you can see they are differently not same. So that is the reason this is not onto. Okay, what about the next one? For example, I am giving you a function fx equal to x plus 1. Okay, tell me, when you have from natural numbers to natural number, now is this onto? Or when you have from integers to integers, now is this onto? When this function will be onto? Function is fx equal to x plus 1. Okay, now in this situation it will be onto, or in this situation it will be onto? Please tell me quickly. So very simple, that in this situation it is not onto. In this situation it will be onto. Okay, yes or no? You can easily see why in this situation it is not onto. It is not onto. Why? Because you can see there is no pre-image of whom? There is no pre-image of 1. Is this clear? You can notice natural numbers are 1, 2, 3, and so on. Okay, so these are the natural numbers. You can see there is no pre-image of 1. Do you agree with me? There is no pre-image of element 1. So very simple, that this is not onto. But when you have integers to integers, this is onto. Why this is onto from integers to integers? Now every element has a pre-image. For example, any element you take, what will be pre-image of 0? Tell me, what will be pre-image of 0? Pre-image of 0 will be -1. What will be pre-image of -1? That will be -2. What will be pre-image of 1? That will be 0. What will be pre-image of 2? That will be 1. What will be pre-image of -2? That will be -3. Yes or no? Is this clear? So this is the point, that when you have integers to integers, then this function fx equal to x plus 1, this is onto, because every element has a pre-image. Yes or no? Whatever element you take, for example, if you take any element y, then what will be pre-image of that element? Tell me. In this function, what will be the pre-image? The pre-image will be y minus 1. This will be the pre-image. Okay, is this clear? Understood? Let me know. Pre-image of 0 will be -1. See, -1 will map to 0. Okay, pre-image of 0 will be -1. You can see pre-image of y will be y minus 1. Okay, in this function. Because remember, x will map to x plus 1. So you can see this will map to y. Okay, remember this element will map to y. So I can say the pre-image of y will be y minus 1. So you can see when you have integers to integers, this function is onto. Okay, let's move on now. Now let's see the bijective function. The another name is bijection, or the another name is one-to-one correspondence. This is a single word. Is this same as one-to-one function? Please tell me. Is this same as one-to-one function? No. This is a single word, one-to-one correspondence. This is an atomic word. You cannot break it. Okay, don't forget this correspondence. This is a single word, one-to-one correspondence. Or you can call it bijective, or you can call it bijection. Now, the definition of bijective function is very simple. That is a function which is injective and which is surjective. Okay, a function which is both injective and surjective, that will be called bijective function. This is the definition of bijective function. Now, tell me one thing. Is this the definition of injective function? Read this and tell me yes or no. Is this the definition of injective function? That every element of codomain has at most one pre-image. Yes, that is correct. From the codomain point of view, injective function definition. that every element of codomain has at most one preimage. This is the definition of surjective function or not? Every element of codomain has at least one preimage. Now, bijective means surjective and injective. So what should I write here? Bijective means surjective and injective. Then what should I write here? I should write exactly one. Yes or no? Because please understand that injective function is saying every element of codomain. See, every element of codomain, every element of codomain. Injective is saying at most one preimage. Surjective is saying at least one preimage. So if I combine these two, if a function is injective and surjective, if I combine these two, what I will get? If a function is injective and surjective, that means it is a bijective function. Then it means every element of codomain has exactly one preimage. Yes or no? Every element has exactly one preimage. So that will be exactly one preimage. This is the definition of bijective function. That every element of codomain has exactly one preimage. Okay. So remember the definition of bijective function. What is that? A function which is injective and surjective. This is the definition of bijective function. You check, is it injective? You check, is it surjective? If both the property are satisfied, then this function is bijective function. But in the GATE exam, they can ask you this definition, right? Do you agree with me? This definition, they can ask you that every element of codomain has exactly one preimage. This is the definition of bijective function. Okay. Now let's move on. So you can easily see in the injective function, what will happen? At most one element of domain is associated with each element of codomain. In the surjective function, what will happen? At least one element of domain is associated with each element of codomain. So in the bijective, what will happen? In the bijective, you can combine these two. In the bijective, it will be exactly one. Okay. So this is what we have seen. You can combine these two. So remember, bijection means injective and surjective. The another name is one-to-one correspondence. This is the another name. Okay. So far we have seen everything: injective, surjective, bijective. Please tell me, did you understand? Look at this function. Is this 1, 1? Tell me, this function, is this 1, 1? This is your domain, this is your codomain. Is this 1, 1? Yes, this is a 1, 1, but this is not onto. Why this is not onto? This function is not onto because this element 2 has no preimage. Okay. That is the reason this is not onto. What about this function? Is this function 1, 1? This function is not 1, 1 because D comma A, they have same image. Different elements have same image. So this is not 1, 1. Okay, but this is onto. Every element is covered. Every element of codomain is covered. What about this function? You can see this function is onto because every element of codomain is covered. And you can notice that every element of codomain has exactly one preimage. Every element of codomain has exactly one preimage. So actually this is bijection. This is actually bijection. Please verify. Look at this. Look at the codomain and tell me how many preimage each element has. Look at this codomain and tell me how many preimage every element has. This has one preimage, this has one preimage, this has one preimage, this has one preimage. So every element of codomain has exactly one preimage. So this is a bijection. What about this? You can see this element is not covered, so this is not onto. Okay, and you can notice that this element and this element, they have same image, so this is not 1, 1. Okay, so this very simple, and this is not even a function. Because of this is not even a function. So I hope you understood all the definitions so far. Is this clear? Please tell me. So far everything is clear. Now let's move on. Now let's see a very important topic, that is functions and cardinalities. So far whatever you have understood, okay, just apply those concepts and tell me the answers for many questions that I will ask you. Okay, back to back a lot of questions I will ask you, remember. So please keep your mind open. All the concepts that we have seen so far, please apply those concepts and tell me the answer for all these questions. First, we will see injective functions and cardinalities. What is the relationship between injective function and the cardinality of the set? Cardinality of the domain and codomain. Okay, so that we will see. Tell me the answer for this question. This is a question, let me know. What is the answer for this question? If domain cardinality is greater than codomain cardinality, can we create some injective function. Take your copy pen and try to create. If domain cardinality is more than codomain cardinality, can we create some injective function? And the answer is no. You cannot create any injective function. For example, look at the domain. I'm giving you domain. This is domain. And the codomain I'm giving you 1, 2 or 1, 2, 3. Now try to create injective function. Can you try? Give me at least one injective function. Give me at least one injective function. This is domain. Domain cardinality is more than codomain cardinality. Give me at least one injective function. Can you give me at least one injective function? Can you create some injective function? Okay, just give me some injective function. Can you give me? The answer is no. Okay, no injective function is possible. No injective function from A to B possible. Okay, can you try to create? Let me try. Let me try. Okay, see, let me map A to 1. Can I map B to 1? Can I do that? Let me map A to 1. Can I map B to 1? No, I want injective function. So I cannot do that. I cannot do that. Okay, because I want injective function. So different elements must have different images. Okay, so let me map B to 2. Can I map C to 1? I cannot do that because I want injective function, and in the injective function, different elements must have different images. So I cannot do that. I cannot do that. So let me do that. Okay, now tell me where you will map D. Where will you map D? If you map this D anywhere, this will not be an injective function, right? Agree with me? So you cannot create any injective function. No injective function, no injective function from A to B possible. Is this understood? So remember, when the domain cardinality is more than codomain cardinality, then we cannot create any injective function. Is this clear? Okay, so remember, no injective function possible. Understood? In this situation, when you have this situation, injective function is not possible. Okay, let's move on. Tell me the answer for this question. If domain cardinality is less than equal to codomain cardinality, can we create some injective function? Okay, just tell me, can we create some injective function? The answer is yes, definitely. Okay, yes, you can create some injective function. See, when the domain cardinality is less than equal to codomain cardinality, okay, you have a domain which has less cardinality. Let's assume A1, A2, A3, and the codomain cardinality is actually greater than or equal to domain cardinality. This is your codomain, and this is your domain. Now, can we create some injective function? I just want some injective function. So, can I say some injective function possible? Let me know. Some injective function possible. Yes, some injective function is possible. You can do like this. Okay, yes, this is an injective function. So, yes, some injective function is definitely possible. Okay, is this clear? So, remember, in this case, can we create some injective function? The answer is yes. Okay, so what is the conclusion then? This is the conclusion, that injective function exists. When injective function will be possible? In which situation injective function will be possible? Injective function exists if and only if domain cardinality is less than equal to codomain cardinality. Do you agree? Do you agree? This is if and only if. We have already seen that if domain cardinality is more than codomain cardinality, then injective function is not possible. And if domain cardinality is less than equal to codomain cardinality, then injective function is possible. So this is if and only if. Injective function exists if and only if domain cardinality is less than equal to codomain cardinality. Understood? This theorem, did you understand? Remember, this is applicable for any set. For any two set, this is applicable. Finite or infinite. Finite or infinite. This is applicable, remember. So this is the definition, that set S cardinality is less than equal to set T cardinality if and only if there exists an injective function from S to T. You can create an injective function from S to T, then it means cardinality of S is less than equal to cardinality of T. Is this theorem clear to everyone? This is important theorem. Please tell me, is this crystal clear to you? With proof we have seen. I've given you the intuitive idea. Now let's move on. Tell me the answer for this question. F is a function from set X to set Y, which is not injective. F is not injective. Then what you can say about X, Y? Cardinality of X, Y. Tell me. F is a function from X to Y, which is not injective. Then what you can say about cardinality of X, Y? So the answer will be option C. This will not be the answer. This will not be the answer. Please focus. Please focus. We are talking about existence of injection. Please focus. We are talking about existence of injection. That remember this. If there exist injective function, okay, if there exists injective function, this existence we are talking about, okay, that the cardinality of S is less than equal to cardinality of T if and only if there exists an injection from S to T. Okay, see this. Read this question now. We are saying F is a function from S to Y, from set X to Y, which is not injective. Yeah, for example, you can create, okay, see, students who are saying option A, okay, see this. If I have this, can I create some non-injective function? Can you create some non-injective function? Can you create some non-injective function? Yes, of course, I can create some non-injective function. So maybe F is this. Maybe F is this. Maybe the question is talking about this F. Is it possible question is talking about this F? Tell me, the question is saying F is a function from X to Y, which is not injective. You can see F is a function from X to Y, which is not injective. Then does it mean that domain cardinality is greater than codomain cardinality? No, of course not. Yes or no? Maybe the question is talking about this F. Is this clear? Please tell me. So you cannot say anything. We can't say anything. Okay. I hope you understood this. So remember, please understand, when domain cardinality is less than codomain cardinality, then there exists an injective function. We are not saying that every function is injective. See, in this situation, you just tell me which statement is correct. Every function is injective or some function is injective. Which statement is correct? Every function is injective or some function is injective. In this situation, some function is injective. Some injective function exists. Understood? Is this crystal clear? Please tell me, because many students have made a mistake here. In this question, a lot of students have made a mistake. So that is the reason I want to ask you again. Is this question clear? Did you understand what this question is asking and why the answer is can't say anything? We can't say anything. Okay, now let me give you the another question. So remember, we are talking about the existence here. Please understand that injective function exists if and only if injective function exists if and only if domain cardinality is less than equal to codomain cardinality. Okay, now let's move on and tell me the answer for this question. F is a function from X to Y which is injective. Now what you can say? F is some function from X to Y which is injective. Now what you can say? Now you can say that answer will be option B. Definitely this is not correct. Okay, now the answer will be option B, because already there is a function which is injective from X to Y. So it simply means the cardinality of domain is less than equal to cardinality of codomain. Okay, so here the answer will be option B, because now the function is existing, injective function is existing. So because injective function exists from X to Y, it means the cardinality of X is less than equal to cardinality of Y. Tell me the answer for this question now. Now I am saying there is no injective function from X to Y. Now I am saying there is no injective function from X to Y. Now you can say answer will be option A. Okay, so did you understand the difference between all these three questions? I have given you three questions. Did you understand the difference between these three questions? Now let's see surjective functions and cardinalities. Okay, so tell me the answer for this question. If domain cardinality is less than codomain cardinality, can we create some surjective function? Can we create some surjective function? And here the answer is no. You can try. See, will you by heart these things? All these things that I'm asking you, will you by heart or can you do it immediately? See, take this. Domain cardinality is less than codomain cardinality. Okay, let me take. This is the domain and this is the codomain. Now, tell me from this set A to set B, can you create some surjective function? Can you give me some surjective function? No, there is no onto function possible, right? No onto function possible. Do you agree with me? Okay, why? What is the reason? See, very simple. In the onto function, I want to cover all the elements of codomain. Can I cover all the elements of codomain? Let me assume A is mapping to 1. Okay, let me assume B is mapping to 2. Now, who will map to 3? Can I do this? Can I do this? This is not even a function. Okay, so I can't do this. This is not even a function. So remember, very simple point that no onto function possible when the domain cardinality is less than codomain cardinality. Understood? Please tell me. These are very intuitive results. So will you ever forget these results? Please tell me. What about this question? Tell me the answer for this question. If domain cardinality is greater than equal to codomain cardinality, can we create some surjective function? The answer is yes. In this case, you can create a surjective function. Okay, very simple. When the domain cardinality is more, for example, A, B, C, and the codomain cardinality is less, now definitely some surjective function you can create. Can I say every function will be surjective? Can I say every function will be surjective? No. I can say some surjective function is there. Some onto function possible. Okay. For example, you can create this onto function. This onto function you can create. So some onto function is possible. Very simple. Can I say every function will be onto? No, every function will not be onto. For example, if this A is instead of this, if A is mapping to 2, then this is not onto. Okay, so remember some onto function is possible. So this is the theorem. Finally, surjective function exists if and only if domain cardinality is greater than equal to codomain cardinality. Did you understand this theorem? All these are important theorems. Do you need to by heart? Is it possible you can forget about this theorem? Let's assume you forget about this theorem. Then what can you do in the gate exam? Immediately, can you find out? For example, this type of example you can create. Yes or no? Assume you forget about this. Okay, then you can easily recall. Yes or no? You can create a diagram and you can easily recall. So remember, this is the theorem that whatever set you take, S comma T are any set, they can be finite or infinite, any set. Okay, S comma T are any set. Then there exists a surjection from S to T. Then what you can say? There exists a surjection from S to T. There exists a surjection from S to T. It simply means what? It simply means S cardinality is greater than equal to T cardinality. Okay, so this is the point. So this is the theorem. I hope you understood. Tell me the answer for this question quickly. F is a function which is not surjective. F is a function from x to y which is not surjective. Now, what can you say about cardinality of x comma y? The answer will be option C. Okay, because again remember, f is a function. Okay, f is a function. For example, you can notice that in this situation, can I say every function will be surjective? Like if I have this situation, in this situation, can I say every function will be surjective? This is A, this is B. Can I say every function will be surjective? No, not every function will be surjective. For example, if you have this function, this is not surjective. This is not onto. Okay. But remember, some onto function is definitely possible. But remember, some onto function possible. Okay. Some onto function possible because domain cardinality is greater than or equal to codomain cardinality. Okay. So now you are getting the point. Okay, now let's move on. Tell me the answer for this question. What is the answer for this question? F is a function which is surjective from x to y. What you can say? So you can see here the surjective function exists. There is at least one surjective function from x to y. So what you can say about the cardinality? You can see the cardinality of x is greater than equal to cardinality of y. Answer will be option B. Let's move on. Tell me the answer for this question. There is no surjective function from x to y. There is no surjective function. It simply means x cardinality is less than y cardinality. Okay, let's move on. Now let's see bijective functions and cardinalities. Tell me the answer for this question. If domain cardinality is greater than codomain cardinality, can you create some bijective function? Can you create some bijective function? The answer is no, but what is the reason? Give me the reason. The answer is no, but give me the reason. See, bijective means injective and surjective. Bijective means injective and surjective. Injective and surjective. So remember, if domain cardinality is greater than codomain cardinality, then injective is not possible. Yes or no? See, injective not possible. Injective function not possible. If injective function is not possible, then bijective function is possible or not? Injective function is not possible, right? So because injective function is not possible here, then the bijective function is also not possible. Very simple. Because bijection means injection and surjection. So in this situation, injective function is not possible. So bijective function is also not possible. What about this? When domain cardinality is less than codomain cardinality, then is bijective function possible? Can we create some bijective function? Again, the answer is no. But what is the reason? Because no surjective function possible. Now there is no surjective function possible. Okay. In this situation, no surjective function is possible. So that is the reason bijective function is also not possible, because bijective function means 1, 1 and on 2. Okay. So this is the idea. Now let's move on. Tell me the answer for this question. If they have same cardinality, then bijective function is possible or not? If they have same cardinality, then bijective function is possible or not? The answer will be yes. Okay, you can easily prove it. See, if they have same cardinality, just think about it, that your domain and your codomain, they have same cardinality. Okay, your domain and codomain, for example, A1, A2, and so on, AN, and they have same cardinality, remember. Now, can you create a bijection? Can you create a bijection? Yes, you can create a bijection. You can do like this: A1 mapping to B1, A2 mapping. Is this a bijection or not? Yes, this is a bijection, right? You can see this is injective because different elements have different images and every element is covered in the codomain. So I can say, yes, this is a bijection. Okay. So very simple point, or I can say one-to-one correspondence. Okay. So remember, yes, bijection exists. In this type of situation, I can say bijection exists. So remember, bijection exists if and only if. When the bijection will exist? Bijection exists if and only if domain cardinality is equal to codomain cardinality. Yes or no? When domain cardinality is equal to codomain cardinality. Very simple. Okay. So remember, bijection means injection and surjection. Tell me what is the condition for injection? Just tell me what is the condition for injection. When injection will be possible? Injection will be possible when domain cardinality is less than equal to codomain cardinality. Okay. And what is the condition for surjection? Tell me what is the condition for surjection. Surjection condition is when the domain cardinality is greater than equal to codomain cardinality. So what will be condition for bijection? Now what will be condition for bijection? You include these two. injection and surjection. So the condition will be domain cardinality is equal to codomain cardinality. Did you understand? See, this condition and this condition, you include these two conditions. Okay, just merge these two conditions, then you will get this condition. Very intuitive. So far, do you need to by heart anything? All these results, do you need to by heart? Very intuitive results, and very easily you can see all these things. Okay, so remember, bijection exists. Bijective function exists if and only if domain and codomain cardinality is same. Okay, is this clear? So remember, if you have any two set, finite or infinite, any two set S comma T, they will have same cardinality if and only if there exists a bijection. There exists a bijection from S to T. Okay. Now let me tell you one more thing. See, this bijection, if you notice, you already know that bijection exists when bijection exists. Bijection exists if and only if you know domain cardinality is equal to codomain cardinality, right? Okay, domain cardinality that is equal to codomain cardinality. This you already know. In this situation, bijection will exist. Okay. Actually, why bijection is called one-to-one correspondence? Let's see. See. Okay, why? Just think about it. Why this bijection is called one-to-one correspondence? Is called one-to-one correspondence. Okay, just think about it. What is the reason why bijection is called one-to-one correspondence? And the reason is actually very simple. Because just look at any bijection. Okay, bijection will exist when they have same cardinality, domain and codomain. So let's assume you have domain and you have codomain. Okay, so let's assume they have four elements. Because bijection exists if and only if they have same cardinality, domain and codomain. Okay, now try to create a bijection. How the bijection will look like? Just try to create a bijection. See, the bijection will look like this. Notice one thing. Let's assume A1 is mapping to B1. Okay, can A2 map to B1? Can A2 map to B1? No. No, because bijection means injection also. So bijection means injection and surjection. So this cannot happen. Okay. So remember, so I can put like this, that A2 is mapping to B2. Next, you can notice, can A3 map to B1? Can A3 map to B1? No, because bijection means injection and surjection. This is not injection. Can A3 map to B2? No, because this is not injection. So A3 is mapping to B3. And finally, A4, can it map to B2? No, because it is not injection. Bijection means injection and surjection. So it will happen like this. Okay, so did you notice? It's like one-to-one correspondence. Couple goals. Yes or no? Like this, one-to-one correspondence. These. So this is the reason bijection is called one-to-one correspondence. Is this clear? This is the reason. Now let me tell you, every bijection you can draw like this. See, every bijection you can draw like this. Very interesting thing that every bijection you can draw in this type of diagram. This every bijection, this beautiful diagram you can create for every bijection. Notice, every bijection is actually, you can draw like this. You can draw in this beautiful format. Okay, like this you can draw. See, let's see. Let's see how. For example, let me take this ABC, ABC. First, you tell me, is this a bijection? Is this a bijection? Yes, this is a bijection. But I'm telling you that every bijection you can draw in this beautiful format. So can you draw this bijection in a beautiful format? Yes, this is a bijection, but can you draw this same bijection in a beautiful format? Beautiful format means this beautiful format, one-to-one. Okay, this one-to-one, one-to-one correspondence. This one-to-one correspondence. So tell me, let me know. Yes, this is a bijection, right? You can see this is onto and injective. Look at this function. This is injective and surjective. But this function I can draw in a beautiful format, no problem. This is A, this is B. All I have to do, just fix this ABC. The domain you fix. Okay, just fix this. Just fix this. Now, this ABC you can put like this, and that's it. Are they same or not? Are they same or not? Yes, they are same. Domain same, codomain same, mapping same. So, finally, you got a beautiful format or not? So, this is your bijection. Same bijection in beautiful format. Same bijection. Same bijection in beautiful format. Okay. So, this is what I'm telling you. So, remember why bijection is called one to one correspondence? Now, did you understand that bijection is called, why bijection is called one to one correspondence? Because every bijection you can ultimately draw in this beautiful format. Understood? Is this clear to everyone? Please tell me. What is the reason bijection is called one to one correspondence? Because every bijection you can draw in this beautiful format. Okay. So this is what I'm telling you now. So remember, whenever this bijection comes to your mind, whenever someone tells you bijection, then which photo should come to your mind? Whenever someone says bijection, then this photo, this beautiful photo, this one to one correspondence photo should come to your mind, where they have the same cardinality. A cardinality is equal to B cardinality. Okay. So very simple. Now tell me the answer for this question. F is a function which is not bijective from x to y. F is a function from x to y which is not bijective. What you can say about their cardinality? The answer will be option C. You can't say anything. See, F is a function which is not bijective. Does it mean no function is bijective? F is a function from x to y which is not bijective. Does it mean no function is bijective from x to y? No. Okay. For example, maybe x is this. See, maybe x, y, maybe x is 1 to 3, y is 1 to 3, and maybe this f is this. So you can easily see this is not bijective. Maybe f is this. Okay. But surely some bijection exists, right? Surely some bijection exist. Okay. Understood? So some bijection definitely exist. So remember, if this particular function is not bijective, it does not mean that no function is bijective. Okay. Maybe the question maker is talking about maybe this function. This function is not bijective, but some bijection definitely exist in this situation. So remember, you can't actually say anything. We can't say anything. Okay. Anything can happen. Tell me. So this is the result that bijection exists if and only if domain and codomain cardinality is same. Tell me the answer for this question. F is a function which is bijective from x to y. Now, from set x to set y, this bijective function exists. So the cardinality will be same. Okay, tell me the answer for this question. There is no bijective function from x to y. No bijective function. Then I can say they have different cardinality. Option B. Okay. Now tell me the answer for this question. True or false? It is given that domain cardinality is equal to codomain cardinality. Now, every function is bijective. The answer is no. Okay. What about this question? Domain cardinality and codomain cardinality are same. Some function is bijective. The answer is yes. Okay. This is true. What about this? Domain cardinality is less than equal to codomain cardinality. Every function is injective. The answer is no. Okay. So this is false. What about this question? Some function is injective in this situation. So here the answer is true. Okay. Tell me the answer for this. Domain cardinality is greater than equal to codomain cardinality. Every function is surjective. The answer is false. But some function is surjective in this situation. The answer is yes. Okay. So this is the complete idea. Understood or not? Tell me. Everything that we have seen so far. Is this crystal clear in your mind? All these theorems, all these results. Okay. And tell me, do you need to by heart anything? Let's assume in the gate exam you forget something. Then immediately can you create these theorems? These theorems can you immediately create with the help of diagram and all these things? Yes or no? So understand, that is the power of understanding. If you by heart something, then in case you forget, you are gone. 2 marks are gone. But remember, these theorems, all these theorems, if you forget, let's assume after 1 month or 2 months, you can immediately create these theorems yourself. Okay, so that is the benefit of understanding. That is the power of understanding concepts. Okay, that is the reason so many students, they get top rank, they get top 100 rank from the Go classes. Okay, because every concept they study by understanding. Okay, not by hearting. So please understand all the concepts, and you will top the gate exam. Okay, now some intuitive results also you can see related to cardinality. Okay, so these are very intuitive. Yes or no? Let's read these. These are intuitive results about cardinality of set. Tell me one thing. Very okay. For example, if these two have same cardinality and C comma B have same cardinality, then A comma C have same cardinality. This is very intuitive, right? Yes or no? Very simple. For example, if A is equal to B, B is equal to C, then A is equal to C. Something like this. Okay, so this second result, very intuitive. Okay, that if set A comma B have same cardinality, B comma C have same cardinality, then A comma C have same cardinality. Okay, in other words, what you can say here, what is there between A comma B? If you want to prove this, then what you will create between A comma B? You will create a bijection. Here also you will create a bijection. Okay, cardinality of A is equal to cardinality of B means there exists a bijection from A to B. Here there exists a bijection from B to C. So there exists a bijection from A to C also. Yes or no? Is this clear? So very intuitive result. Also, what about this? This is also very intuitive result, that if cardinality of B is less than equal to cardinality of A, and cardinality of C is less than equal to cardinality of B, then cardinality of C is less than equal to cardinality of A. Okay, is this clear? Both the results are very intuitive. I want to ask you one thing. If you want to prove this, what you will do? If you want to prove that cardinality of B is less than equal to cardinality of A, what you need to do? What you need to do? You need to create a injective function from B to A. Yes or no? Just create at least one injective function from B to A. That automatically means cardinality of B is less than equal to cardinality of A. Okay, so these are intuitive results about cardinality of set. Very simple. So this is the final conclusion. Remember, conclusion and important results. We have seen everything. So two set have same cardinality if and only if there exists a bijection between them. Also, cardinality of A is less than equal to cardinality of B if and only if there exists a injective function, one-to-one function from A to B. And these are very intuitive results about cardinality of set. Okay, and remember, all these results will work for any set, finite or infinite. Okay, all these results, they will work for finite or infinite, for any type of set. Is this clear? Finite or infinite, any type of set. These results will work for finite or infinite, any type of set. So these results will always work. Okay, so we have seen all these things. Now let's see the next topic, that is counting functions. Now we will see how to count the number of functions. First, we will see counting the total number of functions from one set to another. How many total number of functions you can create? Tell me the answer for this question. How many functions are there from this set to this set? Can you create multiple functions? Let me know. From this set ABC to ABCDE, can you create multiple functions? Definitely you can create multiple functions, right? But total, how many functions you can create? See, you can create many functions from ABC to ABCDE. this is ABC, this is ABCDE. A lot of functions actually you can create. For example, you can create this function. This is a function. Okay, you can create another function, ABC to ABCDE. You can create another function. For example, you can create this function. You can create another function, ABC to ABCDE. You can create another function. Okay, and so on. So total how many functions you can create? That is the question. Okay, so the idea is actually very simple. See, from ABC, this is your domain. This is the domain, and this is the codomain ABCDE. Tell me one thing. I want to create function. Now let me know, if I want to create a function, then this element has how many choices? See, if I want to create a function, then every element of domain, must map to exactly one element of codomain. So this element of domain has how many choices? I can do this, or 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 I can do this. Yes or no? Can I do this like this? Can I do like this? No, I cannot do. So remember, for this element, there are five choices. There are five ways. This I can do, or 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 this I can do. So there are five ways for A. Now, once I have done for A, let's assume for A I have done this. Once I am done with A, now for B, how many choices are there? Once I am done with A, now for B, how many choices are there? Again, there are five ways. I am asking for functions. Can I map B to B? Yes, I can. Yes, here also. This also possible. This also possible. This also possible. So again, there are five ways. Yes or no? Let me assume I'm mapping B to C, B to D. Now tell me, once these are done, A is done, B is done. Now, how many choices for C? Now, how many choices for C? Again, there are five ways. I can map like this, or 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 I can map like this. So, finally, how many total functions I can create? Total number of functions. Tell me, number of functions. I'm asking what is the number of functions that will be 5 multiplied by 5 multiplied by 5. Yes or no? 5 choices for A, 5 choices for B, 5 choices for C. The answer will be 5 into 5 into 5, that is 5 power 3. Notice one thing. This is actually codomain cardinality, power domain cardinality. Yes or no? This is actually 5 power 3. That is actually codomain cardinality, power domain cardinality. Yes or no? This is codomain cardinality. This is domain cardinality. So this is your 5 power 3. Okay, let's move on. So I hope you understood. Tell me the answer for this question. How many functions are possible from ABCDE to ABC? Again, very simple. From this set ABCDE to this set ABC, how many functions? I want to create a function. Then tell me, function means every element of domain must have exactly one image. Yes or no? So in this situation, just tell me how many choices for A? This A I can map here, or I can map here, or I can map here. So for this A, there are actually three ways, or there are three choices. Once I am done with A, let's assume I am mapping A with A. Now, once this is over, now tell me how many choices for B. Again, there are three choices for B. Okay, because I can map B here, or I can map B here, or I can map B here. So remember, again, there are three choices for B. Let's assume I'm mapping B here. Now, once these are done, how many choices for C? Again, there are three choices for C. Okay, similarly, there are three choices for D, and there are three choices for E also. Okay, is this clear? So, what are the number of functions? What will be number of functions? You can see three choices for this, three for this, and so on. So, finally, it will be 3 into 3 into 3 into 3 into 3. That will be 3 power 5. That is same as domain, codomain cardinality. Again, you can see codomain cardinality, power domain cardinality. Okay. Yes or no? Now let's move on. So tell me the answer now. Counting the number of functions m comma n, these are finite set with cardinality. M cardinality is m, n cardinality is n. Number of functions from m to n, what that will be? Number of functions. Number of functions from m to n. So that will be codomain cardinality power domain cardinality. Okay, codomain cardinality power domain cardinality. And that is codomain cardinality power domain cardinality. Yes or no? So this is your answer. Is this clear? This is the number of functions. And why? What are the reason? Can you prove it? Yes, of course, you can easily prove it. See, very simple. You have a function from m to n where cardinality of m is actually small m and cardinality of n is actually small n. Now, in this situation, you can easily see that this is your set m, this is your set n. Okay, this has total m elements. Like let me assume a1, a2, and so on, am, and this has b1, b2, and so on, bn. Now tell me quickly, how many choices for this? This element you can map here or here and so on here. So actually there are total how many ways? Total n choices for a1, total n choices for a2, and so on. There are total n choices for am. So number of functions that will be n multiplied by how many times? How many times? N power m. That is same as codomain cardinality power domain cardinality. Okay. So this is the idea. I hope you understood. Now let's move on. Let's count the number of injective function. Now we are going to count the number of injective functions. So tell me the answer here. How many injective functions are there from this set to this set? Tell me. How many injective functions we have from this set to this set? The answer is zero. The answer is zero. No injective function is possible, right? You already know that injective function is possible if and only if injective function exists. Function exists if and only if. When it will exist? It will exist if and only if domain cardinality is less than equal to codomain cardinality. In this situation, the injective function exists. Otherwise, the injective function will not exist. Tell me the answer for this question. How many injective functions are there from ABC to ABCDE? Okay, this is your domain ABC and this is your codomain ABCDE. Now tell me how many functions? Injective function I won't remember. Remember, I want injective function. If I want injective function for A, how many choices I have? Remember, different elements of domain must map to different elements of codomain. So for this A, how many choices I have? There are 3 choices for A, right? I can map A, sorry, there are 5 choices for A because A I can map to anywhere. Okay, I can map A to A or A to B or A to C or A to D or A to E. So there are 5 choices for A. Now, once I am done with A, now how many choices for B? Once I am done with A, now how many choices for B? Now I cannot do this because I want injective function. So different elements of domain must have different images. So there are 4 choices for B. Okay, and once I am done with B, now how many choices for C? There are only 3 choices for C. So number of injective functions, that will be how many? How many? So you can see 5 multiplied by 4 multiplied by 3. This will be your answer. Okay, is this clear? This is going to be your answer. Please tell me, understood? Okay. So how many terms are there here? That is same as number of elements in the domain, right? Okay, number of elements in the domain. So anyway, this is your answer. Okay, now, so let's count the number of injective function. You have m comma n. Now tell me, I want injective function, number of injective functions. I want number of injective functions. Number of injective functions. What that will be? Number of injective functions. Tell me, first case, when I want injective functions from m to m, remember, from set m to set n. Okay, so tell me, if the cardinality of m is greater than the cardinality of n, now in this case, what will be the answer? In this case, what is going to be the answer? Then answer will be 0. Okay. Otherwise, if this is less than equal to this, in this case, what will be the answer? Okay. In this case, what will be the answer? What is going to be the answer? See, very simple. Very simple, that you have a function from m to n. Okay. Where I am saying that cardinality of m is less than equal to cardinality of n. Okay. Now, let's assume that here you have total m elements, a1, a2, and so on. Total m elements. And here you have total n elements. Total n elements. Where, remember, okay, remember, this is the situation. Now, let's find the injective functions. Let me find the injective function. So I want injective function. Remember, I want injective. Okay, I want injective. So tell me, how many choices for A? A1. For this A1, how many choices I have? This A1 has total n choices, right? A1 can map to this, or A1 can map to B2, or A1 can map to Bn. So there are n choices for A1. Tell me how many choices for A2. Once this A1 is done, once this A1 is done, now for A2, how many choices? Now for A2, there are n minus 1 choices. Okay. And so on. For A3, how many choices? For A3, how many choices? N minus 2 choices. Okay, like this. For AM, how many choices will be there? See, A1 has n choices, A2 has n minus 1 choices, A3 has n minus 2 choices. So AM will have how many choices? That will be m minus n minus m minus 1. Do you agree? Please understand. A1 has n choices, means n minus 0. A2 has n minus 1. A3 has n minus 2. So AM will have n minus m minus 1. Agree? Okay, so finally, number of this 1 to 1 function, what that will be? What that will be? That will be n multiplied by n minus 1 multiplied by n minus 2, and so on. What the last term? What will be the last term? That will be n minus m plus 1. Do you need to remember this, or can you do it immediately in the GATE exam? Like, will you remember this, or can you do it immediately? We have seen the proof, so now you can do it immediately. So this is the answer. Okay. Is this clear? Did you understand this? This is the number of 1 to 1 functions. N minus 1, and so on, n minus m plus 1. Okay. You will see this. One thing you will see actually, in combinatorics, you will see this. Let me tell you. So first of all, let me tell you the answer here. The answer will be n multiplied by n minus 1, and so on. What is the last term? That is n minus m plus 1. This is the answer. Okay, this is the answer. In combinatorics, you will study this. Okay, in combinatorics. In combinatorics, you will study this value n into n minus 1, and so on, n minus m plus 1. This value, it is also written as npm. Don't worry, you will see this. Okay, you will see this in the combinatorics. This is also written n factorial divided by n minus m factorial. Okay, don't worry about it. For now, You do not have to worry about it. Did you understand this proof? Let me know. See, A1 has total n choices. A1 can map to B1 or Bn, anyone. Now, once this A1 is done, A2 has n minus 1 choices. Once this A2 is done, this A3 has n minus 2 choices, and so on. This will have n minus m minus 1 choices. So finally, that will be this value. So number of one-to-one function will be this value. Okay, you don't have to remember this. You can do it immediately. Okay, and remember, in the combinators, you will see this value that we have seen, that is actually this. But don't worry about it right now. Okay, don't forget about it. Forget. Okay, let's move on now. Let's see the counting the bijective functions. Okay, so how many bijective functions are from this set to this set? Please tell me the answer quickly. How many bijective functions are there from this set to this set? The answer is 0. No bijective function exists. Yes or no? Because remember, bijective function exists if and only if what? Bijective function exists if and only if what should happen? Domain cardinality must be same as codomain cardinality. Okay, if and only if domain cardinality is equal to codomain cardinality, in this situation bijective function will exist. Okay, now tell me the answer for this one. How many bijective functions? Again, the answer is 0. What about this one? From ABCD to ABCD, how many bijective functions are there? Now bijective function exist or not? Tell me, now the bijective function will exist or not? Yes, it will exist. Yes or no? Because domain cardinality is equal to codomain cardinality. So bijective function will definitely exist. Let's create the bijective function. A, B, C, D, A, B, C, D. Tell me, okay, I want to create a bijective function. How many choices for A? Let me know how many choices for A. There are 4 choices. Yes or no? We have 4 choices for A. Agree? Because you can map A to anywhere. See, you can do this, or you can do this, or you can do this, or you can do this. So I can map A to anyone. Now let's assume I have done this. Now, once I'm done with A, now how many choices B has? Once I'm done with A is mapping to B. Now how many choices B has? Now it has 3 choices. Yes or no? There are 3 ways. Because I do this? Can I do this? No, I cannot do this because bijection is also injection. Every bijection is also injection, so I cannot do this. Okay, let me do this. Now tell me, how many choices for C? There are 2. And how many choices for D? There are only 1. So what is your final answer? How many bijections? How many bijections? That will be 4 into 3 into 2 into 1. And in your childhood, you have seen this equation. This is your favorite, 4 factorial. Don't worry, in the combinatorics, you will study this. This is called 4 factorial. Okay, is this clear? So your answer is 4 into 3 into 2 into 1. Is this clear? Please tell me. Let me know. Okay, let me tell you another way to prove this. Do you remember what I told you about bijection? Bijection has a very beautiful structure or not? Where you fix this, okay, and by every bijection has this beautiful structure or not? Yes. Okay. So what you do, you fix this. A, B, C, D. This order is fixed. Okay, this order is fixed. You fix this order. This order is fixed. Now, here I want to put A, B, C, D in how many orders? I can put in any order. Yes or no? So if you have seen in your school life, then for these 4 elements, how many orders are possible? If you have 4 elements, how many orders are possible? Like this order is possible A, B, C, D, or maybe this order is possible B, C, D, A. Okay. Or maybe this order is possible A, C, D, B. So how many orders are possible? That is 4 factorial, right? Yes or no? Okay, so here, how many orders possible? That will be 4 factorial. So that is your another answer. So this is how you can find the bijective functions. Did you understand both the methods? At least one method you understand. See, did you like this method where I am finding choices? For this element, I have 4 choices. I want bijective function. So every bijective function is injective and surjective. So this element has 4 choices. Once I am done with this element has only 3 choices. Once I am done with these two elements, this element has only 2 choices, and this element has 1 choice. So your answer will be 4 into 3 into 2 into 1. That is 4 factorial. So this is one way to find the number of bijective functions. And this is another way to find the number of bijective functions. What you do, the domain order you fixed, okay, you fix this domain order, this you fix, and then you can easily put this codomain you can put in any order. Okay, this codomain you can put in any order because every bijection has this beautiful structure. Every bijection has this beautiful one-to-one correspondence structure. So did you understand both the methods? Which method did you like? Both the methods are giving you the same answer, 4 factorial, 4 factorial. Which method did you like? Understand both of them. Okay, just understand both of them. Whichever you like, you can apply. So now tell me, what will be the number of bijective functions? Let's see the number of bijective functions from m to n. Okay, from m to n, the number of bijection functions. The number of bijections. So how many bijections you can create? That will be like this. Tell me, if m is greater than n, how many? 0, right? If m is less than n, how many? 0, right? But if m is equal to n, then how many? That will be m factorial, or you can say n factorial. Both are same. M comma n are same. So you can say m factorial or n factorial. Okay. This is the number of bijections. So tell me the answer for this question. How many injective functions are there from 1 to 3 to 1 through 3, 4, 5? That we have already seen. 5 into 4 into 3. This we have already seen. Now let's move on. Now counting surjective functions. So far we have counted total number of functions. We have counted number of injective functions. We have counted number of surjective functions. Sorry, we have counted number of bijective functions. Did we count number of surjective functions so far? So far, did we count number of surjective function? We did not count, right? Because counting number of surjective function is a bit complicated, and that we will study in the combinatorics module. Okay, this counting surjective function, this is actually a part of combinatorics. So in the combinatorics, we will study this. So do not worry about it right now. In the combinatorics, it will be clear. Now let's move on. Tell me the answer for this GATE exam question. This is GATE 1998 question. The number of functions from m element set to n element set, that will be n power m. Okay, it simply means the codomain cardinality power domain cardinality. We have already seen this. So the answer will be option C. Let's move on. Tell me the answer for this question. How many one-to-one functions are there from set A to itself? From set A to itself. Tell me. How many one-to-one functions? So this actually you can do it immediately. You can do it immediately. Okay. So there are n elements here. This is your set A, which has total n elements. And here also you have total n elements because A to A. We want to count A to A. Yes or no? We want to count A to A. Now let's use our method. So tell me, for this A1, how many choices I have? I want injective function, remember. So for this A1, I can map here, or I can map here, or I can map here. So there are n choices, n ways. For A2, how many? N minus 1 ways. Notice, once I'm done with A1, now A2 has n minus 1 ways. Okay, and so on. This n will have how many? Okay, and so on. This will only have one way. Okay, because actually, if you remember here, you must have n minus m minus 1 ways. Do you remember? Do you remember this? But m is equal to n now. Yes or no? Clear? So that is the reason only one way. So your final answer, how many injective functions? How many injective functions from A to A? How many injective functions from A to A? That will be n multiplied by n minus 1 multiplied by n minus 2 and so on 1. Okay. This is your favorite n factorial. This is your favorite n factorial. Okay. So for this question, the answer that is your favorite n factorial. But you can easily prove it. Okay. Let's move on. Tell me the answer for this question quickly. Let fn equal to 2 for n less than equal to 2. Means when n is less than equal to 2, then the function value is basically 2. Fn equal to fn plus 1, fn minus 1, fn minus 2 plus 1. Compute the values of fn for n less than equal to 6. Okay. First of all, you tell me what is f1. That is already given. F1 is 2. Okay. Because for n less than equal to 2, fn is 2. Okay. Yes or no? See this. See this. For n less than equal to 2, fn is equal to 2. So f2 is equal to 2. Okay. Now the question is also saying what is f3? Tell me what is f3. See, the question is saying that fn equal to fn minus 1 plus fn minus 2 plus 1. Okay, so what will be f3? F3 will be f3. I put 3 here. If I put 3 here, then f3 will be f2 plus f1 plus 1. That is 2 plus 2 plus 1. That is 5. Okay, what will be f4? Tell me quickly, what will be f4? F4 will be f3 plus f2 plus 1. That is 5 plus 2 plus 1. That is 8. Okay. Similarly, you can find f5. What that will be? F5, what that will be? F5 will be 8 plus 5 plus 1. That is 14. And what will be f6? That will be 14 plus 8 plus 1. And that value is 23. Okay. So this is another question, simple question, right? Let's solve this question also. Another very simple question. For n less than equal to 2, fn is 1. Okay. Fn is 1 for n less than equal to 2. What it means? It means what is f1? That is 1. What is f2? That is also 1. Okay. Now the what is the value of f3? See, the question is saying that fn is equal to 2 fn minus 1 minus 1. Now, if I put n equal to 3, then it will be 2 f2 minus 1. That is 2 multiplied by f2 minus 1, and that will be 1. Okay. What will be f4? F4 will be 2 into f3 minus 1. That also will be 1. Similarly, f5 will be 2 f4 minus 1. That also will be 1. You can check it out. Okay. So the all will be 1 actually. Okay. Here, all fi will be 1. Simple. Okay. Let's move on now. Now let's see function composition. What is function composition? Let's start. So let me tell you function composition. This will give you a new function. This is a way to create new function. So what we are going to do now, what we are going to study now we will study function composition. And remember this function composition, this is a way to create new function. Transitively, we can create a new function. Okay, so function composition, this is an operation to create new function. This is an operation to create new function. New function. Okay, so what this function composition does, let me tell you what this does. See, this does like this. If you have two functions, let's assume you have f from a to b, and let's assume you have function g from b to c. Now, what this function f will do? Please notice you have a function f and you have a function g. Okay, from a to b, there is function f. You have function f. And there is another function from b to c. From B to C, there is another function, that is G. Now what you can do? You can create a new function transitively. See what, okay, what you can do? F is there, G is there. Now a new function you can create. See what this F will do. F will relate like this. X is mapped to Y. What this G will do? G will map elements of B to C. So G will do this. This Y is mapped to Z. Now, what this composition says? This composition says that from these two functions, I can create a new function. Okay, that new function will be like this, that X is mapping to Z. Okay, so remember, the new function will be like this. The new function that you will create, new function from F comma G. I am creating new function from F comma G, and that will be like this, that A, okay, C, that will be like this, that X is mapping to Z. So did you understand what this composition says? See, you are creating a new function, okay, from F comma G. This is F, this is G, and what you are doing, you are creating a new function from F comma G, okay, like this, that this X is mapping to Z. This is the new function that you have created. So very simple idea, that function composition, this is the operation to create a new function. Okay, so remember, this composition actually creates new function transitively. This composition creates new function transitively. What that means, let me tell you. That means like this: if you have a function from set A to set B, and there is another function from set B to set C, okay, you have these functions. So this is set A, this is set B, this is set C. There is this function F, there is this function G. Okay, now what will happen? See, this F will do like this, because F is mapping elements of A to element of B, right? Because F is from A to B. So F is mapping X to Y. Okay, what this G is doing? This G is mapping elements of B to elements of C, because G is from B to C. So G is mapping Y to Z. Now what this new function will do? A new function you can create like this. From A to C, you can create a new function. Okay, you can create a new function. Let me call it H. Let me call it H. Okay, I am calling it H. This new function you can create. And what this new function will do? This new function is from A to C, remember, from this set to this set. And what this function will do? It will relate like this, that elements of this X will be related to Z. Okay, in H. In H. So this is the point. Okay. Now, what is the name for this H? Let's find out the name for this H. You tell me, in this H, what is the image of A? What is the image of X? In this H, in this function H, what is the image of X? Remember, new function. This new function is from A to C. From here to here. This new function we have created. Okay, so what is Hx? Hx is Z. Now you tell me one thing. To find out this Hx, which function you applied first? Means on this X, first what you will apply? First what you will apply? On this X, first you will apply F. Okay, first you will apply F. What you will get? What you will get? See, on this X, first you will apply, on this X, first you will apply F. You will get Y. On this Y, this is your Y, remember, this is your Y. On this Y, what you are applying? You apply G. On this Y, you apply G. Then you will get, finally you will get Z. Yes or no? Finally you will get Z. So remember, that is the reason this H is written as GOF. GOF. Okay, this is how we write H equal to GOF. GOF. Because first you apply F, then you apply G. Means GOF. First you apply F, then you apply G. Okay, first you apply F, then you apply G. So finally, this H is called GOF, GOF function. Okay, so I hope you understood. See, let's see this example. What is the composition? Let's understand. Notice this. This is a function from website to company name. Okay, let me call this first function f. Yes or no? Let me call this function f. Okay. Now, this is another function or not? From company name to mobile. Yes or no? Let me call this function g. Now tell me transitively, can I create a new function h? Yes or no? Transitively, I can create a new function. See, f, what this function is doing? This is mapping website to company name. What this function g is doing? This is mapping company name to mobile. So I can create a new function I can create. Look at this new function. This is mapping website to mobile directly. This new function h, okay, this new function h, we have created a new function h which is mapping website to mobile directly. Okay, now in this h, actually first what we are applying, tell me, on any element, like on this Google, first what you will apply? First you will apply f. Yes or no? Agree with me? See, if I ask you what is hx, then that will be like this. First you will apply f, then you will apply g, then you will apply g. That is the reason, that is the reason h is also called, this new function is also called gof. Okay, gof, because first you apply f, then you apply g, so that is the reason it is called gof. I hope you understood. So you can see this is the new function we got. Remember, this is the new function we got. This is you got gof. Okay, from website to mobile directly, new function you got. So this is the definition of gof. I hope you understood. Okay, is this clear? The function composition. So let me just quickly tell you. When you have this situation, f is from a to b and your g is from b to c, then which function you can apply? Which function composite, using the composition, which new function you can create? Using the composition, see, f is from a to b. Just create the diagram. Immediately you can create the diagram. F is from a to b. This is your function f, and this is your function g. So your new function will be like this. Like this. This is your new function. Okay, your new function. Let's call it h. This will be from set A to set C. For this new function, what is the domain? For this new function, what is the domain? The domain for this new function is A. And the domain for this new codomain for this new function is C. Okay, so you have basically created a new function. And you can notice, if I ask you what is hx, then to find hx, what you are going to do, just do step by step. I want to find what is hx. Remember, this is what I want to find. I want to find what is hx. Okay, so to find hx, first where you will go? To find hx, first you will find fx. Okay, yes or no? First you will find fx. First you will find fx. After that, what you will do? Then you will find g of fx. Okay, so that is the reason I can say this h, we call it gof. Very simple, very simple. Okay, and remember this, that whenever you have this gof x, that is same as gofx. Okay, very simple. Also, one more thing, when you will have fog, to define fog, what you need? To define fog, I want fog. To define this fog function, what I need? Fog. This O stands for composition, remember? Remember, this O stands, when you write this gof, here this O stands for composition. This is the composition operation. Okay, and that is same as GOFX. So tell me, if you want to define fog, then what you need? Just create a diagram. Okay, let's create a diagram. Let me create a diagram. I want fog. Means first what I will apply? If I want fog, then first what I will apply? On any element, first I will apply G, right? Then I will apply F, right? Okay. Yes or no? This is your fog. First I will apply G, then I will apply F. So tell me, here you tell me, very simple. So in this situation, I say that G must be from A to B and F must be from B to C. So to define fog, G must be from A to B and F must be from B to C. In this situation, you can define fog, right? Agree or not? Okay. So understood? Please tell me. Did you understand? This is your fog and gof. I hope you got this idea. So remember fog x, that is same as f of gx. And remember gof x, that is same as g of fx. Okay. So this is your final conclusion, that transitively we are getting a new function. Okay. You can easily see. So transitively we are getting a new function fog. In the fog, first you will apply g, then you will apply f. Okay, remember in the fog, first you apply G, then you apply F. So this diagram you can see. Okay. Now, one more thing. This function composition is associative. Okay, function composition that is associative means if I ask you what is FOGOF or maybe GOH, okay, that will be same as, this is going to be same as if I ask you FOGO, okay, if I ask you FOGOH. Okay, so remember function composition is associative. Function composition associative. Simple. Is this clear? So this is associative. Now let's move on. Now, is this necessary that fog and gof will be same? First of all, you tell me, if f is from A to A, G is from A to A, then are gof and fog both defined? F is from A to A, G is from A to A. Can I say gof and fog both will be defined? Yes, both will be defined, right? But both will be defined, remember, because f is from A to A, G is from A to A. So fog, comma, gof both are defined, remember. But will they be same? Not necessarily. Okay, not necessarily. You can see if your fx is 2x, gx is x plus 1, then what will be gof x? Notice that if your, I am saying f is from A to A and G is from A to A, so fog, comma, gof both are defined. Okay. Now the question is saying that fx is equal to 2x and gx is equal to x plus 1. Now what will be fog x? What that will be? Fog x means f of gx, f of gx, f of gx. What is gx? Gx is x plus 1. What is f of x plus 1? F of x plus 1, that will be 2 into x plus 1, that is 2x plus 2. Okay, what will be go of x? What that will be? Go of x. Go of x will be g of fx. Okay, g of fx is what? Fx is 2x. So what will be g of 2x? G of 2x will be g of 2x. Instead of x, you put 2x. Okay, so that will be 2x plus 1. So you can notice they are different. Okay, so remember gof, comma, fog, they may be same, may not be same. Okay, is it necessary they will be same? The answer is no. Okay, the answer is not necessarily. Simple. Okay, let's move on. Now let's solve this question. The question is asking, this is a UGC NET exam question. F comma g functions are given to you from set of integers to set of integers. Okay, they are defined. Fx is given to you, gx is given to you. Now the question is asking composition of f and g, composition of g and f. Okay, question is asking composition of f and g, composition of g and f. Now, first of all, you tell me, I want to ask one thing. Let's find fog, comma, gof. Okay, read this question. This is UGC NET 2013 question. F comma g are given to you. So this f is from integers to integers and g is from integers to integers. Okay, The question is saying that fx is 2x plus 3, and the question is saying that gx is 3x plus 2. Okay, tell me what will be fog x? What will be fog x? Quickly tell me. What is going to be fog x? You know that fog x will be f of gx. Now, what is gx? Gx is 3x plus 2. What is f 3x plus 2? Here, instead of x, you put 3x plus 2. Okay, so it will be 3x plus 2 plus 3. So that is going to be how much? 6x plus 7. Okay, what will be go of x? Go of x, that is go fx. What is go of x? See, go fx is what? Fx is 2x plus 3. Okay, so tell me now, go 2x plus 3. Instead of x, you put 2x plus 3. So you will get, instead of x, you put 2x plus 3. So you are getting 6x plus 11. Okay. Now let's come back to the question. We got fog is, remember, we got fog, that is 6x plus 7, and we got go of, which is 6x plus 11. Now tell me what is the answer? Anyone? The answer is option A or option B? The answer, that is option A or option B. Which of the following is the answer? What do you think? Answer A or option B? Option A or option B? See, what is composition of F and G? What is composition of F and G? When I say composition of F and G, and when I say composition of G and F, what that is? This will be go for fog. This will be go for fog. Tell me. This will be go for fog. Okay, let me tell you. This is a dumb question. This UGC NET question, this is absolutely dumb question. Let me tell you. Okay, this is a misconception, or I can say this is a confusion. This is not a misconception, this is a confusion. What is composition of F and G? If I write F and G, will it be fog or will it be golf? Will you consider this or will you consider this? Which will you consider? Which is correct? Right? You might be thinking, which is correct? Yes or no? Agree? Which is correct? Fog or golf? Okay, actually, both are correct. Okay, both are correct. Let me tell you. For example, if you see Kenneth Rosen, this is the book Kenneth Rosen. In the Kenneth Rosen book, actually, when they say function composition of F and G, here they want to say fog. Okay, are you getting my point? In this Kenneth Rosen book, this is the book Kenneth Rosen. In this Kenneth Rosen book, when they write composition of F and G, they want to say fog. But this is Stanford article. This is from Stanford. You can see. Okay. In this, you can see when they are writing composition of F and G, they are writing golf. Are you getting my point? So actually, this statement is ambiguous. When you say composition of F and G, this statement is actually ambiguous. Is this clear? When you say composition of F and G, remember, this can be fog or this can be golf. It depends on the author. Is this clear? It depends on the author. So this statement is actually ambiguous. Okay. So remember, both are correct. Both are correct. If you calculate fog, that is also correct. If you calculate golf, that is also correct. Both are correct. Is this clear? So let's come back to this question. This UGC NET question. This question is really ambiguous. If you let me promise you one thing. If this same question comes in the GATE exam, what answer they will give? Let's assume, first of all, this question will not come in the GATE exam. This question will not come in the gate exam, in gate future. Okay, let's assume this question by chance, if this question comes in the gate exam, then you will get marks for this also, you will get marks for this also. Okay, so remember, you will get marks for option A comma B. If you do A, then also you will get marks. If you do B, then also you will get marks. That, first of all, in the gate this question will not come. Okay, gate and TIFR, these are good exams, let me tell you. This gate exam and TIFR exam, Tata Institute of Fundamental Research, these are really very good exams. These questions are created by professors. TIFR, Tata Institute of Fundamental Research, those questions are created by TIFR professors. And gate exam questions are created by IIT, IISc professors. Okay, but I don't know who creates UGC NET questions. In this question, this is really a dumb question. Okay, this is really a dumb question. First of all, this question is not created by a professor. Some person has created this question, and I don't know who has created, but let me tell you, this person has studied one resource. Okay, this person has studied one resource, one particular book this person has studied, and this person has created a creative question in this person's mind. A creative question he has created. Okay, F and G, G and F I will ask, and more creativity he has put in the options. More creativity he has put in the options. He has given this also, this also. Okay, so you can see, oh, by following only one resource, only one standard resource this person has studied, and this person has put both the options to make it creative. Okay, to make it tricky question. Okay, this person must be very proud. I have created a very tricky question, right? Okay, so anyway, this is a dumb question, and this is the problem when you study only from one resource, because there are some concepts which are author dependent. Okay, so that is the reason in the Go classes, whatever we teach you from several resources. We follow many different resources we follow. That is the reason all these things we can tell you. Okay, is this clear? So remember, this type of question will not come in the gate exam. But tell me one thing, what do you think? If you are UGC NET student, okay, you are preparing for UGC NET, and in this exam, in this UGC NET exam, if you are there, then which option you will take? Just read question maker's mind. Please read question maker's mind. What do you think? This person has studied Kenneth Rosen or Stanford. What do you think? This person who has created this dumb question, what do you think? This person has studied Stanford or Kenneth Rosen? Definitely this person has studied Kenneth Rosen. Okay. So because Kenneth Rosen is very popular, so that is the reason most of the people, most of the Indian people, they study Kenneth Rosen. Okay, so that is the reason. This question maker thinks that composition of F and G means fog, and composition of G and F means golf. Is this clear? This question maker is thinking fog, golf. So this question maker will give you answer for option A. Okay, is this clear? If you are a UGC NET student, if you are in those UGC NET exam, if you are sitting in UGC NET exam, then remember, the question maker is basically thinking from Kenneth Rosen point of view. Okay, so in the UGC NET exam, you can put option A. But in the GATE exam, which option you will put? In the GATE exam, you will get marks for option A, B. For both of them, you will get the marks. Okay, so do not worry. For option A, option B, both of them, you will get the marks. Actually, in the GATE exam, this type of ambiguous question will not come. If this question comes, they will not give you these two options simultaneously. Okay, one of them will be there. These two options, they will not give you. Okay, so now, is this clear? Please tell me, is this point clear that composition of F and G, this statement is ambiguous? Okay, it can mean fog, it can mean golf, that will depend on the author. Okay, so if you are thinking it is fog, that is also fine. If you are thinking it is golf, that is also fine. Is this clear? Is this point clear? Please tell me. A student was asking, before I started this class, a student was asking, sir, what is composition of F and G? So now you tell me, that is fog or golf? Okay, that is both. Okay, because it is ambiguous. Composition of F and G, this statement is ambiguous. Okay, so in the GATE exam, if they ask you any question, they will ask you fog or they will ask you golf. They will not ask you composition of F and G. Okay, this ambiguous statement they will not give you. So don't worry about it. Okay, now you can easily see here under this question, this UGC NET question, right? Okay, this UGC NET question, if you see the answer on Gate Overflow, okay, you can see this answer is according to Kenneth Rosen. This answer is according to Kenneth Rosen, and this answer is according to the Stanford article. So that is the beauty of dumb questions. Okay, is this clear? Let me know. Please tell me. Understood? Now let's move on. Now let's solve this question. This is UGC NET. Another question. What the question is asking? HOGOF, HOGOF. First of all, will you find both of them differently? Tell me. The question is asking. The question is asking HOGOF. Also, the question is asking HOGOF. Will you calculate this and this separately? Will you calculate these two separately? No, don't do that, because they will always be same. We have already seen composition is associative, right? Function composition, that is associative. So this we have already seen. Okay, so remember this is associative, so you don't have to calculate differently. Now let's calculate only one of them. So tell me, okay, let's calculate HOGOF. First you calculate GOF. What that will be? GOF, that will be GFX. What will be FX? What is FX given? FX is x power 4. Okay, now what will be G x power 4? So instead of x, you put x power 4. Then what you will get, instead of x, you are putting, instead of x, okay, instead of this x, you are putting x power 4. So you will get x power 8 plus 1. This is your GOF. So we have found GOF. Okay, now let's put GOF here. So it will be HO, or I can say, okay, so we have already found GOF. GOF is square root of x power 8 plus 1. Now, in this h, you put this in place of x. Okay, in place of x, you put this. So what you are going to get? You are going to get, instead of x, you can put this. So you will get this 72. So your answer will be x square plus 73. Answer will be option D. Okay, is this clear? So very simple question, right? Very simple. Now the last topic, that is function inverse. This is the last topic in functions. Let's see this topic also. What is function inverse? The name itself is telling you now you need to do the inverse of a function, right? See, when you have a bijective function, this is a bijection or not? Tell me. Yes, this is a bijection. Okay, because you can notice this is injection and surjection. So this is a bijection. Now when you have this bijection, this is a one-to-one correspondence. In this situation, you can create inverse function. What will be inverse function? See, what this original function is doing. This is your function f. What this original function is doing? This original function, if you notice, this is from these actresses to the names. Yes or no? Is this clear? I can say these pictures to names. Right? So this function is from pictures to names. And remember, this is a bijection. This function is a bijection function. Okay. Now you tell me, if I do the reverse mapping, means what I do, I just do the reverse mapping. This reverse mapping I do, this will be called inverse. That's it. Okay. If I do the reverse mapping, that's it. This is called inverse. Now this will be called F inverse. We will call it F inverse. So remember F inverse, that is from names to pictures. That is from names to pictures. Is this clear? Very simple. So remember, very simple point, that whenever you have a bijection, this is a bijection because this is injection and surjection. So this is a one-to-one correspondence. Now you can notice this function f, what this is doing? This is mapping pictures to names. Okay, so this is a bijective function which is mapping pictures to names. But if I see the reverse direction, just look at the reverse direction, that is from names to pictures. Okay, this reverse direction is called F inverse. Very simple. Okay, and remember, to define F inverse, you need bijection. Okay, so remember, to define F inverse, what you need to define F inverse, F must be bijective. F must be bijective. Okay, what is the reason? F must be bijective. If you want to define F inverse, then f must be bijective. What is the reason? See, the reason is very simple. Look at this. Is this bijective? Just look at this and tell me, is this bijective? Look at this. This is not bijective, right? Okay, this is not bijective. Now tell me, in the reverse direction, is this even a function? See, this function f is given to you. In the reverse direction, is this even a function? Is this even a function? In the reverse direction. In the reverse direction, this is not even a function. Agree? Yes or no? Okay, in the reverse direction. In the reverse direction, this is not even a function. Agree with me? Okay. Similarly, you tell me this is a function f. This is a function f. Is this bijection? Is this bijection? Again, this is not bijection. Okay. Now tell me, in the reverse direction, is this even a function? In the reverse direction, is this even a function? In the reverse direction. In the reverse direction, you can check this is not even a function. Okay. But here you can notice this is bijection. Now tell me, in the reverse direction, see, this is a function f. Now tell me, in the reverse direction, is this a function? In the reverse direction, is this a function? Yes, this is a function, right? Okay, so that is the reason I'm telling you that to define f inverse, f must be injective. Okay, f must be injective. Sorry, f must be bijective. To define f inverse, f must be bijective. Okay, is this clear? So remember one thing, f inverse exists, that automatically means that is same as f is invertible. I can say f is invertible. F is invertible. And f is invertible if and only if f is bijective. Is this clear? Okay. So these things are same. These things are same. F inverse exists if and only if f is invertible. We will say that f is invertible. And f is invertible if and only if f is bijective. So when f is bijective, then f inverse exists. Okay. And how to find f inverse? Tell me how to find f inverse. Let me know. To find f inverse, what you will do? First of all, f inverse is defined for only bijective functions. Yes or no? First of all, it is defined only for bijective functions. Only for bijective functions. Okay. Now, remember, if you want to find f inverse, very simple, just reverse the mapping. Just reverse mapping done by f. Okay, very simple. That if you have this f, and let's assume this is bijection. This is your function f. And of course, this is bijection, because to define f inverse, you need a bijection. So this is your function f. Okay, so remember, f is from a to b. F is from a to b. If you want to find the f inverse, then what you do? Just reverse the mapping done by f. Okay, reverse the mapping done by f. So for f inverse, what will happen? For f inverse, you will just reverse the mapping done by f. This will be your f inverse. Your f inverse will be like this. For example, if this is a1, this is b1, then in your f inverse, b1 will map to a1. Okay. If this is a2, this is b2, then in the f inverse, b2 will map to a2. Okay, and so on. So like this, just reverse the mapping, that's it. So this f inverse will be from where to where? This f inverse will be from set b to set a. Okay, is this clear? From set b to set a. Very simple. So this is the simple idea. If f is bijective, why I need bijective? Because to define inverse, I need bijective function. So if f is bijective, then remember, this is the photo. You can see that f is bijective. Okay, from set a to set b, this is your f. Then what this f will do? F will do this x you will map to y. And what f inverse will do? So remember, this will be done by f. And what f inverse will do? F inverse will do this. F inverse will do this. Okay, is this clear? So this is the simple point. Also remember one thing, this f inverse, this is just a notation for inverse. This is just a notation for inverse of f. Okay, or I can say inverse of f means reverse mapping of f, right? Okay, that is reverse mapping of f. Okay, so remember this f inverse. Okay, don't think that this is 1 by f. No, is this clear? Don't think that this is 1 by f. This is a single, this is just a notation, nothing else. This is not power minus 1. Don't say, okay, don't say that f power minus 1. Okay, don't say that. Is this clear? Okay, so remember, this is just a symbol for reverse mapping of f. That's it. Now let's move on. So remember, f is invertible if and only if it is bijective. So invertible and bijective, they are same. If they ask you, is f invertible? You just have to check, is f bijective? These two things are same. And remember, if f is invertible, means f is bijective, then how to find inverse of f? To find inverse of f, all you need to do, just do the reverse mapping of f. Okay, just find the reverse mapping of f. So this is the definition. Now let's see this example. This function, tell me on your screen, is this invertible? On your screen, this function f is given to you. You can notice this function f, it is from set A to set B, A, B, C, 1, 2, 3, and this function f is given to you. F A is 2, F B is 3, and F C is 1. Yes, this is bijective. Bijective is same as invertible. So yes, this is invertible. Now, what will be the inverse? Now let's find the inverse. If you want to find inverse, then what you will do? Find inverse means F inverse. Okay. So tell me, if you want to find inverse, very simple, just do the reverse mapping. Okay, from B to A. Remember, F inverse will be from B to A. Now this B will become the domain. Okay, all you have to do, just do the reverse mapping. 1, 2, 3, A, B, C. Okay, just do the reverse mapping. This A1 will map to C, this 2 will map to A, and this 3 will map to B. Okay, just do the reverse mapping. This is your F inverse. So this is very simple idea. In the F inverse, I can say F inverse of 1 will be C. Okay, simple, right? Okay, now let's move on. Now, let me tell you how to find inverse of a function. Okay, very short trick I can give you to find inverse of a function. Very quickly, you can find inverse of a function. First of all, you tell me if you know, okay, just tell me this point. If you know that fx is x square plus 1, then what will be fy? If you know this, then what will be fy? Tell me what will be fy? That will be y square plus 1. Yes or no? What will be fz? That will be z square plus 1. Okay, yes or no? Very simple, right? This you already know. Very simple. Now let's see how to find inverse of a function. Very simply you can find. Okay, in the question, what will be given to you? Invertible function will be given to you. Okay, so remember what will be given in the question? Invertible function f will be given. Invertible function f will be given. Tell me one thing. If function is not bijective, can the question ask for inverse? If the function f is not bijective, then can the question ask for inverse? No, the question cannot ask for inverse. So if the question is asking for inverse, it means you have an invertible function f. Okay, and the question will ask what? And what will be the question? The question will be find f inverse. Okay, the question will ask you find f inverse. So actually fx will be given to you, and the question will ask you find f inverse x. And the method is actually very simple. This is the simple method. See, fx is given to you, right? Okay, fx will be given to you. Fx will be given to you. Let's call it y. Let's call it y. Okay, now what will be f inverse y? See, fx is y. Fx is y. So from here, what will be x? From here, x will be what? That will be f inverse y. Is this clear? Okay, so very simple. Now, once from here you find f inverse y, okay, you find whatever you find, then what you will do? Then from here you can just replace f inverse x. Yes or no? Is this clear? For example, see, once you have f inverse, notice. If your f inverse y is y square plus 1 or y square plus y, now tell me, what will be f inverse x? Now tell me, if you find this is your f inverse y, then what will be your f inverse x? That will be your x square plus x. Yes or no? Agree? Okay, is this clear? So very simple. So this is what I'm telling you, that the method is actually very simple. The given function, remember, the given function is fx. Okay, and what we have to find? We have to find f inverse x. This is what we have to find. And what the method? All you have to do, just create this. See, fx is already given to you. Something will be given to you. Let's call it y. Okay, so you can notice fx equal to y. So from here, what will be f inverse y? F inverse y will be x. Is this clear? F inverse y will be x. From here, you find f inverse y. Okay, from here you find f inverse y, something. And then what you can do, you can replace y with x. Okay, and then what you can do, you can replace y with x. Is this clear? So this is a simple method. Let's try this on this question. F z to z fx equal to x plus 1. Is this invertible? Quickly tell me. On your screen, this function from integers to integers, fx equal to x plus 1. Is this function invertible? Yes, this function is invertible because this is bijective. You can check, this is injective and surjective. So this function is actually bijective. Okay, so that is the reason this is invertible. Now, because this is invertible, so now we have to find f inverse x. What we have to find? We have to find f inverse x. Okay, the method, see, the method, I told you, what was the method I told you? Method is extremely simple. Fx is given to you. Fx is given to you. Just assume this is y. Yes or no? So tell me, fx equal to y. So from here, what is y? F inverse y. So what is f inverse y? Let me know. F inverse y is x. Yes or no? Now what is x? From here, what is x? X is y minus 1. So remember, x is y minus 1. So what we got? So what we got? We got f inverse y is equal to y minus 1. Now can you find f inverse x? Let me know. Just replace y with x. This is f inverse y. So f inverse x will be, just replace y with x. So that will be x minus 1. Isn't it very simple method? Let me know. See, very simple method. It is given. Fx is given to you. The question will ask you f inverse x. Very simple. This fx is given to you. Just assume this is y. So you can see fx equal to y. That means x equal to f inverse y. Okay. And from here, you just find f inverse y. And at the end, you can replace x, y with x. Okay. You can replace this. So very easily you can do this. Let's solve this question. Is this invertible? Function from real number to real number, fx equal to x square. Is this function invertible? This is not invertible. The reason is very simple. F is not bijective. It is not even injective. Not injective. Why? Because you can notice f2 is equal to f minus 2. This is not onto also. This is not onto also. Why? Because there is no pre-image of negative numbers. There is no pre-image of negative numbers. Okay. So you can see this is not invertible. If this is not invertible, can we find f inverse x? F inverse x, this is a undefined. Okay. Is this clear? We can't define f inverse x for this function f. So very simple. This is not even one to one. This is not onto. Okay. What about this question? You can check it. Is this invertible? First of all, this function from real number to real number, this is actually invertible. This is actually bijection. Okay, and bijection is same as invertible. So this is invertible. Okay, you can check it. You can take it as a homework. You can check it. Now we have to find inverse function. The method I told you, the method I've already told you. See, fx is given to you. That is 4x minus 1. Just assume this is y. So tell me, what will be f inverse y? That will be x or not? Yes or no? F inverse y, that will be x. From here, what is x? From here, what is x? X is 5 plus 1 by 4. Okay, so you can see what you got. You got f inverse y is equal to y plus 1 by 4. Now, can you find f inverse x? Now, can you find f inverse x? Yes, you can find f inverse x. Okay, very easy. Yes or no? Do you agree with me? Finding inverse is very easy. This fixed method you have to apply. This fixed same method you have to apply. Very simple. Now let's solve this gate exam question quickly with this method. This is gate 1996 question. Let R denote set of real numbers. You have a function from R cross R to R cross R. First, you understand this function. What is the domain of this function? What is the domain of this function? That is R cross R. What is the codomain of this function? That is also R cross R. Okay. So remember, first you understand this function, then we will solve it. So you have a function from R cross R to R cross R. Okay. Your domain is R cross R. This is the domain. Okay. This is your R cross R domain. Remember, R cross R means cross product of R comma R. So you have ordered pairs here. For example, 2 comma 3. For example, minus 2 comma 5. For example, 1 comma 1. Okay. For example, minus 0.3 comma 1.7 and so on. Okay. So this is your R cross R. Okay. And from R cross R to R cross R, you have this function f. You have this function f. Okay. So tell me, what will be image of 2 comma 3? What will be that? What will be image of 2 comma 3? See, the question is saying that the question is saying image of x comma y, f x comma y. Image of x comma y is already given to you. What is that? Image of x comma y is x plus y, x minus y. Okay, is this clear? Image of x comma y, that is x plus y, x minus y. So tell me, what will be the image of 2 comma 3? What will be that? That will be 5 comma minus 1, right? Yes or no? So remember, the image of this will be 5 comma minus 1. What will be image of 2 minus 2 comma 5? That will be 3 comma minus 7. Okay, is this clear? What will be image of this element? That will be 2 comma 0. Is this clear? Please tell me, did you understand? So first you understand this function. So we have understood this function, that this function is mapping this element xy to x plus y, x minus y. Okay, so this is your function. Now the question is asking, what is the inverse of this function? Tell me one thing. Tell me one thing. The question is giving you information f is invertible or not. Do you have to check f is invertible or not? Do you need to check f is invertible or not? You don't have to check. Already it is given in the question. Already it is given in the question that f is invertible, because bijective means invertible. So it is already given in the question that f is invertible. So you don't have to find whether f is invertible or not. You directly have to find inverse. Okay, so we will just apply our method. Remember, f of x comma y is x plus y, x minus y. Okay, and in our method, what we do to find inverse? To find f inverse x, what was the method? Let me know. The method was very simple. See, fx is given to you. Just assume this is y. Okay, and from here, x will be f inverse y, or I can say f inverse y will be equal to x. Yes or no? From here, you find f inverse y, and then just replace this y with x. Okay, so this was the idea, if you remember. Okay, yes or no? So the same idea we will apply here. But now what happened? Now we have ordered pairs. Okay, now we have ordered pairs. So remember, f x comma y is given to you, that is x plus y, x minus y. So we will apply, we will assume this is y. Yes or no? I told you fx equal to y, assume fx equal to y. So what I will assume here, should I write y? I should write something. Already y is used. Already y is used. Actually, I should write some ordered pair. Agree with me? Do you agree with me? Because the question has ordered pairs. Okay, yes or no? Do you agree with me? The question has ordered pairs. The domain has ordered pairs. The codomain has ordered pairs. Domain, comma, codomain, they are R cross R. Domain, comma, codomain. We have R cross R. So remember what I will do? I will assume M, comma, N. The same method. See, to find f inverse x, what you do? Fx is already given to you. Assume that is y. So the same thing we are doing. That fxy is given to you. So just assume that is M, comma, N. Okay. Now from here, fx comma y is M, comma, N. From here, what you got? From here, what you got? You got x comma y is equal to what? You got, what you got? Tell me. You got f inverse M, comma, N is equal to x comma y. Do you agree? F inverse M, comma, N is equal to x comma y. Yes or no? Now let's find. See, this equation is already given to you. Okay, notice one thing. X plus y, x minus y. This we are assuming M, comma, N. Yes or no? This we are assuming M, comma, N. So from here, M is equal to x plus y. N is equal to x minus y. From here, what is x? Let me know. What will be x? Just solve these equations. If you add these equations, then you will get 2x equal to m plus n. If you add these two equations, just add these two equations, you will get 2x equal to m plus n. So here x will be m plus n by 2. Okay. And if you subtract from this equation, if you remove this equation, what you will get? You will get 2y equal to m minus n. So here y is equal to m minus n by 2. So I got x also, I got y also. Okay, so remember from here what I got? From here, from this equation, what I got? I got x m plus n by 2. I got y m minus n by 2. So I can write here x comma y. I can write m plus n by 2, m minus n by 2. Okay, yes or no? Is this clear? Please tell me. Is this clear? So this is what I can do. So finally, this is what I got. I got f inverse m comma n. F inverse m comma n, that is equal to m plus n by 2, m minus n by 2. Now what I need to do? The question is asking for f inverse x comma y. The question is asking f inverse x comma y. What I need to do? Very simple. Just replace this with x. Just replace this with y. Agree? F inverse x comma y, that will be x plus y by 2, x minus y by 2. So this is your final answer. For this question, the answer will be option C. Okay, is this clear? Is this understood? So that's it. So this is how you can find inverse of any function. Okay. Take this question also just quickly. Fn is given to you, that is a bijection from z to even integers. So is this Fn invertible? Fn equal to 2n. This is a bijection from integers to even integers. So is this invertible? Yes, bijection means invertible. Okay, so now let's find out F inverse. So remember Fn is given to you, that is 2n. Okay, let's find F inverse n. We need to find F inverse n. Okay, so very simple, very simple. Fn is given to you. Just assume this is y. Okay, from here, what is F inverse y? From here, what is F inverse y? F inverse y is n. And from here, what is n? N is y by 2. So just put n equal to y by 2. So you got F inverse y is equal to y by 2. Okay. Now what I can do? I want F inverse n. I want f inverse n. So I can replace this y with n. So this is the answer I will get. Okay. Similarly, can you do G inverse? Can you find G inverse? Yes, you can easily find G inverse also. Again, G is a bijection from integers to odd integers. You need to find G inverse. Let's do the same thing. Gn is given to you, that is 2n plus 1. Okay, the question is asking find G inverse n. Okay, so that you can very easily do. What you can do? Very easily, Gn is given to you, that is 2n plus 1. Just assume that is y. Okay, so from here, remember, Gn you are assuming y. Okay, so from here, what you got? You got G inverse y equal to n. And from here, what you got? You got n equal to y minus 1 by 2. So just put this y minus 1 by 2. Okay, so I have G inverse y equal to y minus 1 by 2. Okay, and from here, I can replace this y with n. I will get n minus 1 by 2. Okay, I can replace this y with n. So I will get n minus 1 by 2. So very simple. So this is your inverse. Tell me the answer for this question quickly. True or false? X comma y are set. F is one-to-one correspondence. Okay, F is one-to-one correspondence. So F is one-to-one correspondence. That simply means it is invertible. It simply means this is invertible. Now tell me, F inverse exists, right? Now F inverse is also one-to-one correspondence. Is this true? Yes, this is true. Okay, very simple, because see, if F is one-to-one, then the reverse mapping will be one-to-one or not. Notice, if F is one-to-one, see, F is one-to-one, then the reverse mapping will be one-to-one or not. Let me know. The reverse mapping is also one-to-one. Yes or no? Agree with me? See, F is one-to-one, then this reverse mapping will be also one-to-one. Understood? Reverse mapping is also one-to-one. So if F one-to-one, very simple, if F one-to-one, then reverse mapping, is also one-to-one. Okay, so very simple. Now let's move on. Tell me the answer for this question. If F is invertible, then what is F inverse again inverse? F inverse again inverse. So that is very intuitive. That will be F. Okay, because first you find F, then F inverse, then again you will get F. Okay, so very simple. That F inverse again inverse, that is F. Tell me the answer for these two questions. The final two questions in this session, the last two questions in this session. A function F is one-to-one and onto if F has inverse. If F has inverse, then it is 1, 1 and onto. Yes, this is true. Because F has inverse means F invertible. See, F has inverse. This simply means F invertible. Here it simply means F is invertible. Invertible means bijection. Invertible means bijection. Okay, so yes, this statement is actually true. What about the second statement? If a function is mapped from A to B, G is not bijection, then can I say that they have different cardinality? The answer will be false. I told you that if this function is not bijection, maybe some other function is bijection. Do you agree with me? See, a particular function from A to B is not bijection. Does it mean no bijection is there? No, maybe there is some other bijection. So remember, we cannot say if this particular function from A to B is not bijection, we cannot say that A comma B have different cardinality. So here the answer will be false. Okay. So that's it. This is your functions summary. We have seen the complete summary of functions. Okay, this is done. This is over. So please tell me, did you understand and did you love it? Let me know. So the complete summary of functions we have done. So, this functions summary lecture. Let me know. Did you love this session? We will put this session on the Go Classes YouTube channel. I request only one thing, that please press the like button and please put a comment. Okay, did you like this summary? This is basically the complete summary of functions. Let me tell you, if anyone watches this particular video, if anyone watches, they can solve all the questions from the functions. Okay, in the gate exam, in the TIFR exam, in any exam, UGC NET, ISRO, in any exam, from functions, any question you can solve if you watch this complete summary also. Okay, so this is the, I can say, complete revision, complete summary. Every point we have covered the types of functions, the terminology, definition of functions, the composition operation, inverse operation, a lot of questions we have done. Okay, so I have told you everything, a lot of tricky questions I have told you. Okay, cardinality and type of function, injection and cardinality, so everything basically I told you. Okay, so I hope you loved this session, and I request only one thing, that when we put this video on the Go Classes YouTube channel, please like and please comment. Okay, please like and comment. Okay, so that will help us, that will motivate us. So this is my request to you. Always, whenever you watch any video on Go Classes YouTube channel, please press the like button and please put a comment. Okay, because we get very less comments if you watch our videos. We put a lot of efforts from the standard resources. We teach you all the concepts, and also basically we teach you all the variations, all the concepts from the standard resources. From many standard resources, we teach you concepts with proof. We teach you, basically we never tell you to by heart anything. Okay, so a lot of effort that we are putting for the students. We are not getting that many comments on our YouTube channel. So please, whenever you are watching any video on the Go Classes YouTube channel, please press the like button, and also please put a comment. Okay, please share your review related to that video. Okay, so thank you so much everyone. I loved having this session, and I hope you loved watching this session. Okay, so thank you so much.